Section 0 of Tractatus Logico-Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C.K. Ogden. Section 0. Introduction by Bertrand Russell. Mr. Wittgenstein's Tractatus Logico-Philosophicus, whether or not it prove to give the ultimate truth on the matters with which it deals, certainly deserves, by its breadth and scope and profundity, to be considered an important event in the philosophical world. Starting from the principles of symbolism and the relations which are necessary between words and things in any language, it applies the result of this inquiry to various departments of traditional philosophy, showing in each case how traditional philosophy and traditional solutions arise out of ignorance of the principles of symbolism and out of misuse of language. The logical structure of propositions and the nature of logical inference are first dealt with. Thence we pass successively to theory of knowledge, principles of physics, ethics, and finally to the mystical (das Mystische). In order to understand Mr. Wittgenstein's book, it is necessary to realize what is the problem with which he is concerned. In the part of his theory which deals with symbolism, he is concerned with the conditions which would have to be fulfilled by a logically perfect language. There are various problems as regards language. First, there is the problem what actually occurs in our minds when we use language with the intention of meaning something by it. This problem belongs to psychology. Secondly, there is the problem as to what is the relation subsisting between thoughts, words, or sentences, and that which they refer to or mean. This problem belongs to epistemology. Thirdly, there is the problem of using sentences so as to convey truth rather than falsehood. This belongs to the special sciences dealing with the subject matter of the sentences in question. Fourthly, there is the question, what relation must one fact (such as a sentence) have to another in order to be capable of being a symbol for that other? This last is a logical question, and is the one with which Mr. Wittgenstein is concerned. He is concerned with the conditions for accurate symbolism, i.e. for symbolism in which a sentence means something quite definite. In practice, language is always more or less vague, so that what we assert is never quite precise. Thus, logic has two problems to deal with in regard to symbolism. 1. The conditions for sense rather than nonsense in combinations of words. 2. The conditions for uniqueness of meaning or reference in symbols or combinations of symbols. A logically perfect language has rules of syntax which prevent nonsense, and has single symbols which always have a definite and unique meaning. Mr. Wittgenstein is concerned with the conditions for a logically perfect language. Not that any language is logically perfect, or that we believe ourselves capable, here and now, of constructing a logically perfect language, but that the whole function of language is to have meaning, and it only fulfills this function in proportion as it approaches to the ideal language which we postulate. The essential business of language is to assert or deny facts. Given the syntax of language, the meaning of a sentence is determined as soon as the meaning of the component words is known. In order that a certain sentence should assert a certain fact, there must, however the language may be constructed, be something in common between the structure of the sentence and the structure of the fact. This is perhaps the most fundamental thesis of Mr. Wittgenstein's theory. That which has to be in common between the sentence and the fact cannot, he contends, be itself in turn said in language. It can, in his phraseology, only be shown, not said, for whatever we may say will still need to have the same structure. The first requisite of an ideal language would be that there should be one name for every simple, and never the same name for two different simples. A name is a simple symbol in the sense that it has no parts which are themselves symbols. In a logically perfect language, nothing that is not simple will have a simple symbol. The symbol for the whole will be a complex, containing the symbols for the parts. In speaking of a complex, we are, as will appear later, sinning against the rules of philosophical grammar, but this is unavoidable at the outset. Most propositions and questions that have been written about philosophical matters are not false but senseless. We cannot, therefore, answer questions of this kind at all, but only state their senselessness. Most questions and propositions of the philosophers result from the fact that we do not understand the logic of our language. They are of the same kind as the question whether the good is more or less identical than the beautiful. 4.003. What is complex in the world is a fact. Facts which are not compounded of other facts are what Mr. Wittgenstein calls Sachverhalt, whereas a fact which may consist of two or more facts is a Tatsache. Thus, for example, Socrates is wise, is a Sachverhalt, as well as a Tatsache, whereas Socrates is wise and Plato is his pupil, is a Tatsache, but not a Sachverhalt. He compares linguistic expression to projection in geometry. A geometrical figure may be projected in many ways, each of these ways corresponding to a different language, but the projective properties of the original figure remain unchanged, whichever of these ways may be adopted. These projective properties correspond to that which in his theory the proposition and the fact must have in common, if the proposition is to assert the fact. In certain elementary ways this is, of course, obvious. It is impossible, for example, to make a statement about two men, assuming for the moment that the men may be treated as simples, without employing two names. And if you are going to assert a relation between the two men, it will be necessary that the sentence in which you make the assertion shall establish a relation between the two names. If we say, Plato loves Socrates, the word loves, which occurs between the word Plato and the word Socrates, establishes a certain relation between these two words, and it is owing to this fact that our sentence is able to assert a relation between the persons named by the words Plato and Socrates. We must not say the complex sign A RB says that A stands in a certain relation R to B, but we must say that A stands in a certain relation to B says that A RB, bracket 3.1432, Mr. Wittgenstein begins his theory of symbolism with the statement, 2.1, we make to ourselves pictures of facts, A picture, he says, is a model of the reality, and to the objects in the reality correspond the elements of the picture. The picture itself is a fact. The fact that things have a certain relation to each other is represented by the fact that in the picture its elements have a certain relation to one another. In the picture and the pictured, there must be something identical in order that the one can be a picture of the other at all. What the picture must have in common with reality in order to be able to represent it after its manner, rightly or falsely, is its form of representation, 2.161, 2.17, We speak of a logical picture of a reality when we wish to imply only so much resemblance as is essential to its being a picture in any sense. That is to say, when we wish to imply no more than identity of logical form. The logical picture of a fact, he says, is a Gedanke. A picture can correspond or not correspond with the fact and be accordingly true or false, but in both cases it shares the logical form with the fact. The sense in which he speaks of pictures is illustrated by his statement, the gramophone record, the musical thought, the score, the waves of sound, all stand to one another in that pictorial internal relation which holds between language and the world. To all of them the logical structure is common (like the two youths, their two horses, and their lilies in the story. They are all in a certain sense one) (4.014). The possibility of a proposition representing a fact rests upon the fact that in it objects are represented by signs, but are themselves present in the proposition as in the fact. The proposition and the fact must exhibit the same logical manifold, and this cannot be itself represented since it has to be in common between the fact and the picture. Mr. Wittgenstein maintains that everything properly philosophical belongs to what can only be shown, or to what is common between a fact and its logical picture. It results from this view that nothing correct can be said in philosophy. Every philosophical proposition is bad grammar, and the best that we can hope to achieve by philosophical discussion is to lead people to see that philosophical discussion is a mistake. Philosophy is not one of the natural sciences. The word philosophy must mean something which stands above or below, but not beside the natural sciences. The object of philosophy is the logical clarification of thoughts. Philosophy is not a theory, but an activity. A philosophical work consists essentially of elucidations. The result of philosophy is not a number of philosophical propositions, but to make propositions clear. Philosophy should make clear and delimit sharply the thoughts which otherwise are, as it were, opaque and blurred. (4.111 and 4.112). In accordance with this principle, the things that have to be said in leading the reader to understand Mr. Wittgenstein's theory are all of them things which that theory itself condemns as meaningless. With this proviso, we will endeavour to convey the picture of the world which seems to underlie his system. The world consists of facts. Facts cannot strictly speaking be defined, but we can explain what we mean by saying that facts are what make propositions true or false. Facts may contain parts which are facts, or may contain no such parts. For example, Socrates was a wise Athenian, consists of the two facts, Socrates was wise, and Socrates was an Athenian. A fact which has no parts that are facts is called by Mr. Wittgenstein a Sachverhalt. This is the same thing that he calls an atomic fact. An atomic fact, although it contains no parts that are facts, nevertheless does contain parts. If we may regard Socrates is wise as an atomic fact, we perceive that it contains the constituents Socrates and wise. If an atomic fact is analysed as fully as possibly (theoretical, not practical possibility is meant), the constituents finally reached may be called simples, or objects. It is a logical necessity demanded by theory, like an electron. His ground for maintaining that there must be simples is that every complex presupposes a fact. It is not necessarily assumed that the complexity of facts is finite, even if every fact consists of an infinite number of atomic facts, and if every atomic fact consisted of an infinite number of objects, there would still be objects and atomic facts. (4.2211). The assertion that there is a certain complex reduces to the assertion that its constituents are related in a certain way, which is the assertion of a fact. Thus, if we give a name to the complex, the name only has meaning in virtue of the truth of a certain proposition, namely, the proposition asserting the relatedness of the constituents of the complex. Thus the naming of complexes presupposes propositions, while propositions presupposes the naming of simples. In this way, the naming of simples is shown to be what is logically first in logic. The world is fully described if all atomic facts are known, together with the fact that these are all of them. The world is not described by merely naming all the objects in it. It is necessary also to know the atomic facts of which these objects are constituents. Given this total of atomic facts, every true proposition, however complex, can theoretically be inferred. A proposition true or false, asserting an atomic fact is called an atomic proposition. All atomic propositions are logically independent of each other. No atomic proposition implies any other or is inconsistent with any other. Thus the whole business of logical inference is concerned with propositions which are not atomic. Such propositions may be called molecular. Wittgenstein's theory of molecular propositions turns upon his theory of the construction of truth functions. A truth function of a proposition P is a proposition containing P, and such that its truth or falsehood depends only upon the truth or falsehood of P. And similarly, a truth function of several propositions P, Q, R, ... is one containing P, Q, R, ... and such that its truth or falsehood depends only upon the truth or falsehood of P, Q, R, ... It might seem at first sight as though there were other functions of propositions besides truth functions. Such, for example, would be A believes P. For in general, A will believe some true propositions and some false ones, unless he is an exceptionally gifted individual. We cannot infer that P is true from the fact that he believes it, or that P is false from the fact that he does not believe it. Other apparent exceptions would be such as, P is a very complex proposition, or P is a proposition about Socrates. Mr. Wittgenstein maintains, however, for reasons which will appear presently, that such exceptions are only apparent, and that every function of a proposition is really a truth function. It follows that, if we can define truth functions generally, we can obtain a general definition of all propositions in terms of the original set of atomic propositions. This Wittgenstein proceeds to do. It has been shown by Dr. Scheffer (Trans. Am. Math. Soc. Volume 14, pages 481 to 488, that all truth functions of a given set of propositions can be constructed out of either of the two functions, not P or not Q, or not P and not Q. Wittgenstein makes use of the latter, assuming a knowledge of Dr. Scheffer's work. The manner in which other truth functions are constructed out of not P and not Q is easy to see. Not P and not P is equivalent to not P. Hence we obtain a definition of negation in terms of our primitive function. Hence we can define P or Q, since this is the negation of not P and not Q, i.e. of our primitive function. The development of other truth functions out of not P and P or Q is given in detail at the beginning of Principia Mathematica. This gives all that is wanted when the propositions which are arguments to our truth function are given by enumeration. Wittgenstein, however, by a very interesting analysis, succeeds in extending the process to general propositions, i.e. to cases where the propositions which are arguments to our truth function are not given by enumeration, but are given as all those satisfying some condition. For example, let fx be a propositional function, i.e. a function whose values are propositions, such as x is human, then the various values of fx form a set of propositions. We may extend the idea, not P and not Q, so as to apply to simultaneous denial of all the propositions which are values of fx. In this way, we arrive at the proposition which is ordinarily represented in mathematical logic by the words, fx is false for all values of x. The negation of this would be the proposition, there is at least one x for which fx is true, which is represented by, there exists symbol x, close bracket, and symbol fx, close quote. If we had started with not fx instead of fx, we should have arrived at the proposition, quote, fx is true for all values of x, close quote, which is represented by, quote, bracket, x, close bracket, and symbol fx, close quote. Wittgenstein's method of dealing with general propositions, square bracket, in essence, quote, bracket, x, close bracket, end symbol fx, close quote, and, quote, bracket, there exists symbol x, close bracket, end symbol fx, close quote, close square bracket, differs from previous methods by the fact that the generality comes only in specifying the set of propositions concerned, and when this has been done, the building up of truth functions proceeds exactly as it would in the case of a finite number of enumerated arguments, p, q, r, ... Mr. Wittgenstein's explanation of his symbolism at this point is not quite fully given in the text. The symbol he uses is square bracket, line over p, comma, line over xi, comma, capital N bracket, line over xi, close bracket, close square bracket. The following is the explanation of this symbol. Line over p stands for all atomic propositions. Line over xi stands for any set of propositions. Capital N bracket, line over xi, close bracket, stands for the negation of all the propositions making up xi. The whole symbol, square bracket, line over p, comma, line over xi, comma, capital N bracket, line over xi, close bracket, close square bracket, means whatever can be obtained by taking any selection of atomic propositions, negating them all, then taking any selection of the set of propositions now obtained, together with any of the originals, and so on indefinitely. This is, he says, the general truth function, and also the general form of proposition. What is meant is somewhat less complicated than it sounds. The symbol is intended to describe a process by the help of which, given the atomic propositions, all others can be manufactured. The process depends upon a. Scheffer's proof that all truth functions can be obtained out of simultaneous negation, i.e. out of, quote, not p and not q, close quote. B. Mr. Wittgenstein's theory of the derivation of general propositions from conjunctions and disjunctions. C. The assertion that a proposition can only occur in another proposition as argument to a truth function. Given these three foundations, it follows that all propositions which are not atomic can be derived from such as are, by a uniform process, and it is this process which is indicated by Mr. Wittgenstein's symbol. From this uniform method of construction, we arrive at an amazing simplification of the theory of inference, as well as a definition of the sort of propositions that belong to logic. The method of generation, which has just been described, enables Wittgenstein to say that all propositions can be constructed in the above manner from atomic propositions, and in this way the totality of propositions is defined. Bracket, the apparent exceptions which we mentioned above are dealt with in a manner which we shall consider later, close bracket. Wittgenstein is enabled to assert that propositions are all that follows from the totality of atomic propositions, bracket, together with the fact that it is the totality of them, close bracket. That a proposition is always a truth function of atomic propositions, and that if P follows from Q, the meaning of P is contained in the meaning of Q, from which of course it results that nothing can be deduced from an atomic proposition. All the propositions of logic, he maintains, are tautologies, such for example as, quote, P or not P, close quote. The fact that nothing can be deduced from an atomic proposition has interesting applications, for example, to causality. There cannot, in Wittgenstein's logic, be any such thing as a causal nexus. Quote, the events of the future, close quote, he says, quote, cannot be inferred from those of the present. Superstition is the belief in the causal nexus, close quote. That the sun will rise tomorrow is a hypothesis, We do not in fact know whether it will rise, since there is no compulsion according to which one thing must happen because another happens. Let us now take up another subject, that of names. In Wittgenstein's theoretical logical language, names are only given to simples. We do not give two names to one thing, or one name to two things. There is no way whatever, according to him, by which we can describe the totality of things that can be names, in other words, the totality of what there is in the world. In order to be able to do this, we should have to know of some property which must belong to every thing by a logical necessity. It has been sought to find such a property in self-identity, but the conception of identity is subjected by Wittgenstein to a destructive criticism from which there seems no escape. The definition of identity by means of the identity of indiscernibles is rejected, because the identity of indiscernibles appears to be not a logically necessary principle. According to this principle, x is identical with y, if every property of x is a property of y. But it would, after all, be logically possible for two things to have exactly the same properties. If this does not in fact happen, that is an accidental characteristic of the world, not a logically necessary characteristic, and accidental characteristics of the world must, of course, not be admitted into the structure of logic. Mr. Wittgenstein accordingly banishes identity, and adopts the convention that different letters are to mean different things. In practice, identity is needed as between a name and a description, or between two descriptions. It is needed for such propositions as, quote, Socrates is the philosopher who drank the hemlock, close quote, or, quote, the even prime is the next number after 1, close quote. For such uses of identity, it is easy to provide on Wittgenstein's system. The rejection of identity removes one method of speaking of the totality of things, and it will be found that any other method that may be suggested is equally fallacious. So at least Wittgenstein contends, and, I think, rightly. This amounts to saying that, quotes, object is a pseudo-concept. To say, quote, x is an object, close quote, is to say nothing. It follows from this that we cannot make such statements as, quote, there are more than 3 objects in the world, close quote, or, quote, there are an infinite number of objects in the world, close quote. Objects can only be mentioned in connection with some definite property. We can say, quote, there are more than 3 objects which are human, close quote, or, quote, there are more than 3 objects which are red, close quote. For in these statements, the word object can be replaced by a variable in the language of logic. The variable being one which satisfies in the first case the function, quote, x is human, close quote. In the second, the function, quote, x is red, close quote. But when we attempt to say, quote, there are more than 3 objects, close quote, this substitution of the variable for the word, quotes, object, becomes impossible, and the proposition is therefore seen to be meaningless. We here touch one instance of Wittgenstein's fundamental thesis, that it is impossible to say anything about the world as a whole, and that whatever can be said has to be about bounded portions of the world. This view may have been originally suggested by a notation, and if so, that is much in its favour, for a good notation has a subtlety and suggestiveness which at times make it seem almost like a live teacher. Notational irregularities are often the first sign of philosophical errors, and a perfect notation would be a substitute for thought. But although notation may have first suggested to Mr. Wittgenstein the limitation of logic to things within the world as opposed to the world as a whole, yet the view, once suggested, is seen to have much else to recommend it. Whether it is ultimately true, I do not, for my part, profess to know. In this introduction I am concerned to expound it, not to pronounce upon it. According to this view, we could only say things about the world as a whole if we could get outside the world, if, that is to say, it ceased to be for us the whole world. Our world may be bounded for some superior being who can survey it from above, but for us, however finite it may be, it cannot have a boundary, since it has nothing outside it. Wittgenstein uses, as an analogy, the field of vision. Our field of vision does not, for us, have a visual boundary, just because there is nothing outside it. And in like manner, our logical world has no logical boundary, because our logic knows of nothing outside it. These considerations lead him to a somewhat curious discussion of solipsism. Logic, he says, fills the world. The boundaries of the world are also its boundaries. In logic, therefore, we cannot say, there is this and this in the world, but not that. For to say so would apparently presuppose that we exclude certain possibilities, and this cannot be the case, since it would require that logic should go beyond the boundaries of the world, as if it could contemplate these boundaries from the other side also. What we cannot think, we cannot think. Therefore, we also cannot say what we cannot think. This, he says, gives the key to solipsism. What solipsism intends is quite correct, but this cannot be said. It can only be shown. That the world is my world appears in the fact that the boundaries of language (the only language I understand) indicate the boundaries of my world. The metaphysical subject does not belong to the world, but is a boundary of the world. We must take up next the question of molecular propositions, which are at first sight not truth functions of the propositions that they contain, such for example as A believes P. Wittgenstein introduces this subject in the statement of his position, namely, that all molecular functions are truth functions. He says, 5.54, in the general propositional form, propositions occur in a proposition only as basis of truth operations. At first sight, he goes on to explain, it seems as if a proposition could also occur in other ways. For example, A believes P. Here it seems superficially as if the proposition P stood in a sort of relation to the object A. But it is clear that A believes that P, A thinks P, A says P, are of the form enumerated arguments P, Q, R, ... P says P, and here we have no coordination of a fact and an object, but a coordination of facts by means of a coordination of their objects. 5.542. What Mr. Wittgenstein says here is said so shortly that its point is not likely to be clear to those who have not in mind the controversies with which he is concerned. The theory with which he is disagreeing will be found in my articles on the nature of truth and falsehood in Philosophical Essays and Proceedings of the Aristotelian Society, 1906 to 1907. The problem at issue is the problem of the logical form of belief, i.e., what is the schema representing what occurs when a man believes? Of course, the problem applies not only to belief, but also to a host of other mental phenomena which may be called propositional attitudes. Doubting, considering, desiring, etc. In all these cases it seems natural to express the phenomena in the form, A doubts P, A desires P, etc. Which makes it appear as though we are dealing with a relation between a person and a proposition. This cannot, of course, be the ultimate analysis, since persons are fictions and so are propositions, except in the sense in which they are facts on their own account. A proposition, considered as a fact on its own account, may be a set of words which a man says over to himself, or a complex image, or train of images passing through his mind, or a set of incipient bodily movements. It may be any one of innumerable different things. The proposition as a fact on its own account, for example, the actual set of words the man pronounces to himself, is not relevant to logic. What is relevant to logic is that common element among all these facts, which enables him, as we say, to mean the fact which the proposition asserts. To psychology, of course, more is relevant. For a symbol does not mean what it symbolizes in virtue of a logical relation alone, but in virtue also of a psychological relation of intention, or association, or what not. The psychological part of meaning, however, does not concern the logician. What does concern him in this problem of belief is the logical schema. It is clear that, when a person believes a proposition, the person, considered as a metaphysical subject, does not have to be assumed in order to explain what is happening. What has to be explained is the relation between the set of words which is the proposition considered as a fact on its own account, and the objective fact which makes the proposition true or false. This reduces ultimately to the question of the meaning of propositions, that is to say, the meaning of propositions is the only non-psychological portion of the problem involved in the analysis of belief. This problem is simply one of a relation of two facts, namely, the relation between the series of words used by the believer and the fact which makes these words true or false. The series of words is a fact just as much as what makes it true or false is a fact. The relation between these two facts is not unanalyzable, since the meaning of a proposition results from the meaning of its constituent words. The meaning of the series of words which is a proposition is a function of the meaning of the separate words. Accordingly, the proposition as a whole does not really enter into what has to be explained in explaining the meaning of a proposition. It would perhaps help to suggest the point of view which I am trying to indicate. To say that in the cases which have been considered, the proposition occurs as a fact, not as a proposition. Such a statement, however, must not be taken too literally. The real point is that in believing, desiring, etc., what is logically fundamental is the relation of a proposition, considered as a fact, to the fact which makes it true or false, and that this relation of two facts is reducible to a relation of their constituents. Thus the proposition does not occur at all in the same sense in which it occurs in a truth function. There are some respects in which, as it seems to me, Mr. Wittgenstein's theory stands in need of greater technical development. This applies in particular to his theory of number, (6.02 ff), which, as it stands, is only capable of dealing with finite numbers. No logic can be considered adequate until it has been shown to be capable of dealing with transfinite numbers. I do not think there is anything in Mr. Wittgenstein's system to make it impossible for him to fill this lacuna. More interesting than such questions of comparative detail is Mr. Wittgenstein's attitude towards the mystical. His attitude upon this grows naturally out of his doctrine in pure logic, according to which the logical proposition is a picture (true or false) of the fact, and has in common with the fact a certain structure. It is this common structure which makes it capable of being a picture of the fact. But the structure cannot itself be put into words, since it is a structure of words, as well as of the facts to which they refer. Everything, therefore, which is involved in the very idea of expressiveness of language must remain incapable of being expressed in language, and is, therefore, inexpressible in a perfectly precise sense. This inexpressible contains, according to Mr. Wittgenstein, the whole of logic and philosophy. The right method of teaching philosophy, he says, would be to confine oneself to propositions of the sciences, stated with all possible clearness and exactness, leaving philosophical assertions to the learner, and proving to him, whenever he made them, that they are meaningless. It is true that the fate of Socrates might befall a man who attempted this method of teaching, but we are not to be deterred by that fear, if it is the only right method. It is not this that causes some hesitation in accepting Mr. Wittgenstein's position, in spite of the very powerful arguments which he brings to its support. What causes hesitation is the fact that, after all, Mr. Wittgenstein manages to say a good deal about what cannot be said, thus suggesting to the skeptical reader that, possibly, there may be some loophole through a hierarchy of languages, or by some other exit. The whole subject of ethics, for example, is placed by Mr. Wittgenstein in the mystical, inexpressible region. Nevertheless, he is capable of conveying his ethical opinions. His defense would be that what he calls the mystical can be shown, although it cannot be said. It may be that this defense is adequate, but, for my part, I confess that it leaves me with a certain sense of intellectual discomfort. There is one purely logical problem in regard to which these difficulties are peculiarly acute. I mean the problem of generality. In the theory of generality, it is necessary to consider all propositions of the form fx, where fx is a given propositional function. This belongs to the part of logic which can be expressed, according to Mr. Wittgenstein's system. But the totality of possible values of x, which might seem to be involved in the totality of propositions of the form fx, is not admitted by Mr. Wittgenstein among the things that can be spoken of. For this is no other than the totality of things in the world, and thus involves the attempt to conceive the world as a whole. The feeling of the world as a bounded whole is the mystical. Hence the totality of the values of x is mystical. (6.45). This is expressly argued when Mr. Wittgenstein denies that we can make propositions as to how many things there are in the world, as for example, that there are more than 3. These difficulties suggest to my mind some such possibility as this, that every language has, as Mr. Wittgenstein says, a structure concerning which, in the language, nothing can be said, but that there may be another language dealing with the structure of the first language, and having itself a new structure, and that to this hierarchy of languages there may be no limit. Mr. Wittgenstein would of course reply that his whole theory is applicable unchanged to the totality of such languages. The only retort would be to deny that there is any such totality. The totalities concerning which Mr. Wittgenstein holds that it is impossible to speak logically are nevertheless thought by him to exist, and are the subject matter of his mysticism. The totality resulting from our hierarchy would be not merely logically inexpressible, but a fiction, a mere delusion, and in this way the supposed sphere of the mystical would be abolished. Such a hypothesis is very difficult, and I can see objections to it which at the moment I do not know how to answer. Yet I do not see how any easier hypothesis can escape from Mr. Wittgenstein's conclusions. Even if this very difficult hypothesis should prove tenable, it would leave untouched a very large part of Mr. Wittgenstein's theory, though possibly not the part upon which he himself would wish to lay most stress. As one with a long experience of the difficulties of logic, and of the deceptiveness of theories which seem irrefutable, I find myself unable to be sure of the rightness of a theory merely on the ground that I cannot see any point on which it is wrong. But to have constructed a theory of logic which is not at any point obviously wrong is to have achieved a work of extraordinary difficulty and importance. This merit, in my opinion, belongs to Mr. Wittgenstein's book, and makes it one which no serious philosopher can afford to neglect. Bertrand Russell, May 1922. End of section 0. Recording by Jeffrey Edwards. Section 1 of Tractatus Logico-Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C.K. Ogden. Section 1. Preface. This book will perhaps only be understood by those who have themselves already thought the thoughts which are expressed in it, or similar thoughts. It is therefore not a textbook. Its object would be attained if it afforded pleasure to one who read it with understanding. The book deals with the problems of philosophy and shows, as I believe, that the method of formulating these problems rests on the misunderstanding of the logic of our language. Its whole meaning could be summed up somewhat as follows. What can be said at all can be said clearly, and whereof one cannot speak, thereof one must be silent. The book will, therefore, draw a limit to thinking, or rather, not to thinking, but to the expression of thoughts. For, in order to draw a limit to thinking, we should have to be able to think both sides of this limit We should therefore have to be able to think what cannot be thought. The limit can, therefore, only be drawn in language, and what lies on the other side of the limit will be simply nonsense. How far my efforts agree with those of other philosophers I will not decide. Indeed, what I have here written makes no claim to novelty in points of detail, and therefore I give no sources, because it is indifferent to me whether what I have thought has already been thought before me by another. I will only mention that to the great works of Frege, and the writings of my friend Bertrand Russell, I owe in large measure the stimulation of my thoughts. If this work has a value, it consists in two things. First, that in it thoughts are expressed, and this value will be greater the better the thoughts are expressed, the more the nail has been hit on the head. Here I am conscious that I have fallen far short of the possible, simply because my powers are insufficient to cope with the task. May others come and do it better. On the other hand, the truth of the thoughts communicated here seems to me unassailable and definitive. I am, therefore, of the opinion that the problems have in essentials been finally solved. And if I am not mistaken in this, then the value of this work secondly consists in the fact that it shows how little has been done when these problems have been solved. L. W. Vienna, 1918. 1. The world is everything that is the case. 1.1. The world is the totality of facts, not of things. 1.11. The world is determined by the facts, and by these being all the facts. 1.12. For the totality of facts determines both what is the case, and also all that is not the case. 1.13. The facts in logical space are the world. 1.2. The world divides into facts. 1.21. Anyone can either be the case or not be the case, and everything else remain the same. 2. What is the case, the fact, is the existence of atomic facts. 2.01. An atomic fact is a combination of objects, entities, things, 2.011. It is essential to a thing that it can be a constituent part of an atomic fact. 2.012. In logic, nothing is accidental. If a thing can occur in an atomic fact, the possibility of that atomic fact must already be prejudged in the thing. 2.0121. It would, so to speak, appear as an accident, when to a thing that could exist alone on its own account, subsequently a state of affairs could be made to fit. If things can occur in atomic facts, this possibility must already lie in them. A logical entity cannot be merely possible. Logic treats of every possibility, and all possibilities are its facts. Just as we cannot think of spatial objects at all apart from space, or temporal objects apart from time, so we cannot think of any object apart from the possibility of its connection with other things. If I can think of an object in the context of an atomic fact, I cannot think of it apart from the possibility of this context. 2.0122. The thing is independent, insofar as it can occur in all possible circumstances, but this form of independence is a form of connection with the atomic fact, a form of dependence. It is impossible for words to occur in two different ways, alone and in the proposition. 2.0123. If I know an object, then I also know all the possibilities of its occurrence in atomic facts. Every such possibility must lie in the nature of the object. A new possibility cannot subsequently be found. 2.01231. In order to know an object, I must know not its external, but all its internal qualities. 2.0124. If all objects are given, then thereby are all possible atomic facts also given. 2.013. Everything is, as it were, in a space of possible atomic facts. I can think of this space as empty, but not of the thing without the space. 2.0131. A spatial object must lie in infinite space. (Bracket). A point in space is an argument place. (Close bracket). A speck in a visual field need not be red, but it must have a colour. It has, so to speak, a colour space round it. A tone must have a pitch. The object of the sense of touch a hardness, etc. 2.014. Objects contain the possibility of all states of affairs. 2.0141. The possibility of its occurrence in atomic facts is the form of the object. 2.02. The object is simple. 2.0201. Every statement about complexes can be analyzed into a statement about their constituent parts, and into those propositions which completely describe the complexes. 2.021. Objects form the substance of the world, therefore they cannot be compound. 2.0211. If the world had no substance, then whether a proposition had sense would depend on whether another proposition was true. 2.0212. It would then be impossible to form a picture of the world, (bracket, true or false, close bracket). 2.022. It is clear that, however different from the real one an imagined world may be, it must have something, a form, in common with the real world. 2.023. This fixed form consists of the objects. 2.0231. The substance of the world can only determine a form, and not any material properties, for these are first presented by the propositions, first formed by the configuration of the objects. 2.0232. Roughly speaking, objects are colourless. 2.0233. Two objects of the same logical form are, apart from their external properties, only differentiated from one another in that they are different. 2.02331. Either a thing has properties which no other has, and then one can distinguish it straight away from the others by a description and refer to it, or, on the other hand, there are several things which have the totality of their properties in common, and then it is quite impossible to point to any one of them. For if a thing is not distinguished by anything, I cannot distinguish it, for otherwise it would be distinguished. 2.024. Substance is what exists independently of what is the case. 2.025. It is form and content. 2.0251. Space, time, and colour, (bracket, colouredness, close bracket) are forms of objects. 2.026. Only if there are objects can there be a fixed form of the world. 2.027. The fixed, the existent, and the object are one. 2.0271. The object is the fixed, the existent. The configuration is the changing, the variable. 2.0272. The configuration of the objects forms the atomic fact. 2.03. In the atomic fact, objects hang one in another, like the links of a chain. 2.031. In the atomic fact, the objects are combined in a definite way. 2.032. The way in which objects hang together in the atomic fact is the structure of the atomic fact. 2.033. The form is the possibility of the structure. 2.034. The structure of the fact consists of the structures of the atomic facts. 2.04. The totality of existent atomic facts is the world. 2.05. The totality of existent atomic facts also determines which atomic facts do not exist. 2.06. The existence and non-existence of atomic facts is the reality. (Bracket). The existence of atomic facts we also call a positive fact, their non-existence a negative fact. Close bracket. 2.061. Atomic facts are independent of one another. 2.062. From the existence or non-existence of an atomic fact, we cannot infer the existence or non-existence of another. 2.063. The total reality is the world. 2.1. We make to ourselves pictures of facts. 2.11. The the picture presents the facts in logical space, the existence and non-existence of atomic facts. 2.12. The picture is a model of reality. 2.13. To the objects correspond in the picture the elements of the picture. 2.131. The elements of the picture stand in the picture for the objects. 2.14. The picture consists in the fact that its elements are combined with one another in a definite way. 2.141. The picture is a fact. 2.15. That the elements of the picture are combined with one another in a definite way represents that the things are so combined with one another. This connection of the elements of the picture is called its structure, and the possibility of this structure is called the form of representation of the picture. 2.151. The form of representation is the possibility that the things are combined with one another as are the elements of the picture. 2.1511. Thus the picture is linked with reality, it reaches up to it. 2.1512. It is like a scale applied to reality. 2.15121. Only the outermost points of the dividing lines touch the object to be measured. 2.1513. According to this view, the representing relation which makes it a picture also belongs to the picture. 2.1514. The representing relation consists of the coordinations of the elements of the picture and the things. 2.1515. These coordinations are as it were the feelers of its elements with which the picture touches reality. 2.16. In order to be a picture, a fact must have something in common with what it pictures. 2.161. In the picture and the pictured, there must be something identical in order that the one can be a picture of the other at all. 2.17. What the picture must have in common with reality in order to be able to represent it after its manner, rightly or falsely, is its form of representation. 2.171. The picture can represent every reality whose form it has. The spatial picture, everything spatial. The colored, everything colored, etc. 2.172. The picture, however, cannot represent its form of representation. It shows it forth. 2.173. The picture represents its object from without, its standpoint is its form of representation, therefore the picture represents its object rightly or falsely. 2.174. But the picture cannot place itself outside of its form of representation. 2.18. What every picture, of whatever form, must have in common with reality in order to be able to represent it at all, rightly or falsely, is the logical form, that is, the form of reality. 2.181. If the form of representation is the logical form, then the picture is called a logical picture. 2.182. Every picture is also a logical picture. On the other hand, for example, not every picture is spatial. 2.19. The logical picture can depict the world. 2.2. The picture has the logical form of representation in common with what it pictures. 2.201. The picture depicts reality by representing a possibility of the existence and non-existence of atomic facts. 2.202. The picture represents a possible state of affairs in logical space. 2.203. The picture contains the possibility of the state of affairs which it represents. 2.21. The picture agrees with reality or not. It is right or wrong, true or false. 2.22. The picture represents what it represents, independently of its truth or falsehood, through the form of representation. 2.221. What the picture represents is its sense. 2.222. In the agreement or disagreement of its sense with reality, its truth or falsity consists. 2.223. In order to discover whether the picture is true or false, we must compare it with reality. 2.224. It cannot be discovered from the picture alone whether it is true or false. 2.225. There is no picture which is a priori true. 3. The logical picture of the facts is the thought. 3.001. Quote, an atomic fact is thinkable, close quote, means we can imagine it. 3.01. The totality of true thoughts is a picture of the world. 3.02. The thought contains the possibility of the state of affairs which it thinks. What is thinkable is also possible. 3.03. We cannot think anything unlogical, for otherwise we should have to think unlogically. 3.031. It used to be said that God could create everything except what was contrary to the laws of logic. The truth is, we could not say of an quotes, unlogical world how it would look. 3.032. To present in language anything which quotes, contradicts logic, is as impossible as in geometry to present by its coordinates a figure which contradicts the laws of space, or to give the coordinates of a point which does not exist. 3.0321. We could represent spatially an atomic fact which contradicted the laws of physics, but not one which contradicted the laws of geometry. 3.04. An a priori true thought would be one whose possibility guaranteed its truth. 3.05. Only we could know a priori that a thought is true if its truth was to be recognized from the thought itself, bracket, without an object of comparison, close bracket. 3.1. In the proposition, the thought is expressed perceptibly through the senses. 3.11. We use the sensibly perceptible sign, bracket, sound or written sign, etc., close bracket, of the proposition as a projection of the possible state of affairs. The method of projection is the thinking of the sense of the proposition. 3.12. The sign through which we express the thought I call the proposition sign, and the proposition is the proposition sign in its projective relation to the world. 3.13. To the proposition belongs everything which belongs to the projection, but not what is projected. Therefore, the possibility of what is projected, but not this itself. In the proposition, therefore, its sense is not yet contained, but the possibility of expressing it. Bracket, quote, the content of the proposition, close quote, means the content of the significant proposition, close bracket. In the proposition, the form of its sense is contained, but not its content. 3.14. The propositional sign consists in the fact that its elements, the words, are combined in it in a definite way. The propositional sign is a fact. 3.141. The proposition is not a mixture of words, bracket, just as the musical theme is not a mixture of tones, close bracket. The proposition is articulate. 3.142. Only facts can express a sense. A class of names cannot. 3.143. That the propositional sign is a fact is concealed by the ordinary form of expression, written or printed. Bracket. For in the printed proposition, for example, the sign of a proposition does not appear essentially different from a word. Thus it was possible for Frege to call the proposition a compounded name. Close bracket. 3.1431. The essential nature of the propositional sign becomes very clear when we imagine it made up of spatial objects, bracket, such as tables, chairs, books, close bracket, instead of written signs. The mutual spatial position of these things then expresses the sense of the proposition. 3.1432. We must not say, quote, the complex sign, quotes, A capital RB, says, quote, A stands in relation capital R to B, close quote, close quote. But we must say, quote, that, quotes, A stands in a certain relation to, quotes, B, says that A capital RB, close quote. 3.144. States of affairs can be described, but not named. Bracket. Names resemble points. Propositions resemble arrows. They have senses. Close bracket. 3.2. In propositions, thoughts can be so expressed that to the objects of the thoughts correspond the elements of the propositional sign. 3.201. These elements I call simple signs, and the proposition completely analyzed. 3.202. The simple signs employed in propositions are called names. 3.203. The name means the object. The object is its meaning. Bracket. A is the same sign as A. Close bracket. 3.21. To the configuration of the simple signs in the propositional sign corresponds the configuration of the objects in the state of affairs. 3.22. In the proposition, the name represents the object. 3.221. Objects I can only name. Signs represent them. I can only speak of them. I cannot assert them. A proposition can only say how a thing is, not what it is. 3.23. The postulate of the possibility of the simple signs is the postulate of the determinateness of the sense. 3.24. A proposition about a complex stands in internal relation to the proposition about its constituent part. A complex can only be given by its description, and this will either be right or wrong. The proposition in which there is mention of a complex, if this does not exist, becomes not nonsense, but simply false. That a propositional element signifies a complex can be seen from an indeterminateness in the propositions in which it occurs. We know that everything is not yet determined by this proposition. Bracket. The notation for generality contains a prototype. Close bracket. The combination of the symbols of a complex in a simple symbol can be expressed by a definition. 3.25. There is one and only one complete analysis of the proposition. 3.251. The proposition expresses what it expresses in a definite and clearly specifiable way. The proposition is articulate. 3.26. The name cannot be analyzed further by any definition. It is a primitive sign. 3.261. Every defined sign signifies, via those signs by which it is defined, and the definitions show the way. Two signs, one a primitive sign, and one defined by primitive signs, cannot signify in the same way. Names cannot be taken to pieces by definition, bracket, nor any sign which alone and independently has a meaning. Close bracket. 3.262. What does not get expressed in the sign is shown by its application. What the signs conceal, their application declares. 3.263. The meanings of primitive signs can be explained by elucidations. Elucidations are propositions which contain the primitive signs. They can, therefore, only be understood when the meanings of these signs are already known. 3.3. Only the proposition has sense. Only in the context of a proposition has a name meaning. 3.31. Every part of a proposition which characterizes its sense I call an expression, bracket, a symbol, close bracket. Bracket, the proposition itself is an expression, close bracket. Expressions are everything, essential for the sense of the proposition, that propositions can have in common with one another. An expression characterizes a form and a content. 3.311. An expression presupposes the forms of all propositions in which it can occur. It is the common characteristic mark of a class of propositions. 3.312. It is therefore represented by the general form of the propositions which it characterizes, and in this form the expression is constant and everything else variable. 3.313. An expression is thus presented by a variable, whose values are the propositions which contain the expression. Bracket, in the limiting case, the variable becomes constant, the expression a proposition, close bracket. I call such a variable a propositional variable. 3.314. An expression has meaning only in a proposition. Every variable can be conceived as a propositional variable, bracket, including the variable name, close bracket. 3.315. If we change a constituent part of a proposition into a variable, there is a class of propositions which are all the values of the resulting variable proposition. This class in general still depends on what, by arbitrary agreement, we mean by parts of that proposition. But if we change all those signs, whose meaning was arbitrarily determined, into variables, there always remains such a class. But this is now no longer dependent on any agreement. It depends only on the nature of the proposition. It corresponds to a logical form, to a logical prototype. 3.316. What values the propositional variable can assume is determined. The determination of the values is the variable. 3.317. The determination of the values of the propositional variable is done by indicating the propositions whose common mark the variable is. The determination is a description of these propositions. The determination will therefore deal only with symbols, not with their meanings. And only this is essential to the determination, that is only a description of symbols and asserts nothing about what is symbolized. The way in which we describe the propositions is not essential. 3.318. I conceive the proposition, like Frege and Russell, as a function of the expressions contained in it. 3.32. The sign is the part of the symbol perceptible by the senses. 3.321. Two different symbols can therefore have the sign, bracket, the written sign or the sound sign, close bracket, in common. They then signify in different ways. 3.322. It can never indicate the common characteristic of two objects that we symbolize them with the same signs, but by different methods of symbolizing. For the sign is arbitrary. We could therefore equally well choose two different signs, and where then would be what was common in the symbolization? 3.323. In the language of everyday life, it very often happens that the same word signifies in two different ways, and therefore belongs to two different symbols, or that two words, which signify in different ways, are apparently applied in the same way in the proposition. Thus the word, is, appears as the copula, as the sign of equality, and as the expression of existence. To exist, as an intransitive verb like to go, identical, as an adjective. We speak of something, but also of the fact of something happening. Bracket, in the proposition, green is green, where the first word is a proper name, as the last an adjective, these words have not merely different meanings, but they are different symbols. Close bracket. 3.324. Thus there easily arise the most fundamental confusions, bracket, of which the whole of philosophy is full. Close bracket. 3.325. In order to avoid these errors, we must employ a symbolism which excludes them, by not applying the same sign in different symbols, and by not applying signs in the same way which signify in different ways. A symbolism, that is to say, which obeys the rules of logical grammar, of logical syntax. Bracket. The logical symbolism of Frege and Russell is such a language, which, however, does still not exclude all errors. Close bracket. 3.326. In order to recognize the symbol in the sign, we must consider the significant use. 3.327. The sign determines a logical form only together with its logical syntactic application. 3.328. If a sign is not necessary, then it is meaningless. That is the meaning of Occam's razor, bracket, if everything in the symbolism works as though a sign had meaning, then it has meaning. Close bracket. 3.33. In logical syntax, the meaning of a sign ought never to play a role. It must admit of being established without mention being thereby made of the meaning of a sign. It ought to presuppose only the description of the expressions. 3.331. From this observation we get a further view into Russell's theory of types. Russell's error is shown by the fact that in drawing up his symbolic rules, he has to speak about the things his signs mean. 3.332. No proposition can say anything about itself, because the propositional sign cannot be contained in itself, bracket, that is the, whole theory of types, close bracket. 3.333. A function cannot be its own argument because the functional sign already contains the prototype of its own argument, and it cannot contain itself. If, for example, we suppose that the function F bracket fx close bracket could be its own argument, then there would be a proposition, quote, F bracket F bracket fx close bracket close bracket close quote. And in this the outer function F and the inner function F must have different meanings, for the inner has the form psi bracket fx close bracket, the outer the form psi bracket phi bracket fx close bracket close bracket. Common to both functions is only the letter quotes F, which by itself signifies nothing. This is at once clear if instead of quote F bracket F bracket u close bracket close bracket close quote, we write quote bracket there exists symbol phi close bracket colon F bracket phi u close bracket end symbol phi u equals F u close quote. Herewith Russell's paradox vanishes. 3.334. The rules of logical syntax must follow of themselves, if we only know how every single sign signifies. 3.34. A proposition possesses essential and accidental features. Accidental are the features which are due to a particular way of producing the propositional sign. Essential are those which alone enable the proposition to express its sense. 3.341. The essential in a proposition is therefore that which is common to all propositions which can express the same sense. And in the same way in general, the essential in a symbol is that which all symbols which can fulfill the same purpose have in common. 3.3411. One could therefore say the real name is that which all symbols which signify an object have in common. It would then follow, step by step, that no sort of composition was essential for a name. 3.342. In our notations there is indeed something arbitrary, but this is not arbitrary, namely, that if we have determined anything arbitrarily, then something else must be the case. Bracket. This results from the essence of the notation. Close bracket. 3.3421. A particular method of symbolizing may be unimportant, but it is always important that this is a possible method of symbolizing, and this happens as a rule in philosophy. A single thing proves over and over again to be unimportant, but the possibility of every single thing reveals something about the nature of the world. 3.343. Definitions are rules for the translation of one language into another. Every correct symbolism must be translatable into every other according to such rules. It is this which all have in common. 3.344. What signifies in the symbol is what is common to all those symbols by which it can be replaced according to the rules of logical syntax. 3.3441. We can, for example, express what is common to all notations for the truth functions as follows. It is common to them that they all, for example, can be replaced by the notations of quotes, not symbol p, bracket, quote, not p, close quote, close bracket, and quote, p or symbol q, close quote, bracket, quote, p or q, close quote, close bracket. Bracket, herewith is indicated the way in which a special possible notation can give us general information. Close bracket. 3.3442. The sign of the complex is not arbitrarily resolved in the analysis, in such a way that its resolution would be different in every propositional structure. 3.4. The proposition determines a place in logical space. The existence of this logical place is guaranteed by the existence of the constituent parts alone, by the existence of the significant proposition. 3.41. The propositional sign and the logical coordinates, that is, the logical place. 3.411. The geometrical and the logical place agree in that each is the possibility of an existence. 3.42. Although a proposition may only determine one place in logical space, the whole logical space must already be given by it. Otherwise denial, the logical sum, the logical product, etc. would always introduce new elements in coordination. The logical scaffolding round the picture determines the logical space. The proposition reaches through the whole logical space. 3.5. The applied thought propositional sign is the thought. End of section 1. Recording by Jeffrey Edwards. Section 2 of Tractatus Logico-Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C.K. Ogden. Section 2. 4. The thought is the significant proposition. 4.001. The totality of propositions is the language. 4.002. Man possesses the capacity of constructing languages, in which every sense can be expressed, without having an idea how and what each word means, just as one speaks without knowing how the single sounds are produced. Colloquial language is a part of the human organism and is not less complicated than it. From it is humanly possible to gather immediately the logic of language. Language disguises the thought, so that from the external form of the clothes one cannot infer the form of the thought they clothe, because the external form of the clothes is constructed with quite another object than to let the form of the body be recognized. The silent adjustments to understand colloquial language are enormously complicated. 4.003. Most propositions and questions that have been written about philosophical matters are not false, but senseless. We cannot, therefore, answer questions of this kind at all, but only state their senselessness. Most questions and propositions of the philosophers result from the fact that we do not understand the logic of our language. They are of the same kind as the question whether the good is more or less identical than the beautiful. And so it is not to be wondered at that the deepest problems are really no problems. 4.0031. All philosophy is, critique of language, but not at all in Mothner's sense. Russell's merit is to have shown that the apparent logical form of the proposition need not be its real form. 4.01. The proposition is a picture of reality. The proposition is a model of the reality as we think it is. 4.011. At the first glance the proposition, say as it stands printed on paper, does not seem to be a picture of the reality of which it treats, but nor does the musical score appear at first sight to be a picture of a musical piece, nor does our phonetic spelling (letters) seem to be a picture of our spoken language, and yet these symbolisms prove to be pictures, even in the ordinary sense of the word, of what they represent. 4.012. It is obvious that we perceive a proposition of the form A R B as a picture, Here the sign is obviously a likeness of the signified. 4.013. And if we penetrate to the essence of this pictorial nature, we see that this is not disturbed by apparent irregularities (like the use of sharp and flat in the score), for these irregularities also picture what they are to express, only in another way. 4.014. The gramophone record, the musical thought, the score, the waves of sound, all stand to one another in that pictorial internal relation, which holds between language and the world. To all of them the logical structure is common. Like the two youths, their two horses, and their lilies in the story, they are all in a certain sense one. 4.0141. In the fact that there is a general rule by which the musician is able to read the symphony out of the score, and that there is a rule by which one could reconstruct the symphony from the line on a gramophone record, and from this again, by means of the first rule, construct the score, herein lies the internal similarity between these things, which at first sight seem to be entirely different. And the rule is the law of projection, which projects the symphony into the language of the musical score. It is the rule of translation of this language into the language of the gramophone record. 4.015. The possibility of all similes, of all the images of our language, rests on the logic of representation. 4.016. In order to understand the essence of the proposition, consider hieroglyphic writing, which pictures the facts it describes, and from it came the alphabet, without the essence of the representation being lost. 4.02. This we see from the fact that we understand the sense of the propositional sign, without having had it explained to us. 4.021. The proposition is a picture of reality, for I know the state of affairs presented by it, if I understand the proposition, and I understand the proposition without its sense having been explained to me. 4.022. The proposition shows its sense. The proposition shows how things stand, if it is true, and it says that they do so stand. 4.023. The proposition determines reality to this extent, that one only needs to say, yes, or no, to it to make it agree with reality. Reality must therefore be completely described by the proposition. A proposition is the description of a fact, as the description of an object describes it by its external properties, so propositions describe reality by its internal properties. The proposition constructs a world with the help of a logical scaffolding, and therefore one can actually see in the proposition all the logical features possessed by reality if it is true. One can draw conclusions from a false proposition. 4.024. To understand a proposition means to know what is the case, if it is true. One can therefore understand it without knowing whether it is true or not. One understands it if one understands its constituent parts. 4.025. The translation of one language into another is not a process of translating each proposition of the one into a proposition of the other, but only the constituent parts of propositions are translated. And the dictionary does not only translate substantives, but also adverbs and conjunctions, etc., and it treats them all alike. 4.026. The meaning of the simple signs, the words, must be explained to us, if we are to understand them. By means of propositions, we explain ourselves. 4.027. It is essential to propositions that they can communicate a new sense to us. 4.03. A proposition must communicate a new sense with old words. The proposition communicates to us a state of affairs, therefore it must be essentially connected with the state of affairs. And the connection is, in fact, that it is its logical picture. 4.031. In the proposition, a state of affairs is, as it were, put together for the sake of experiment. One can say, instead of, this proposition has such and such a sense, this proposition represents such and such a state of affairs. 4.0311. One name stands for one thing, and another for another thing, and they are connected together, and so the whole, like a living picture, presents the atomic fact. 4.0312. The possibility of propositions is based upon the principle of the representation of objects by signs. My fundamental thought is that the logical constants do not represent, that the logic of the facts cannot be represented. 4.032. The proposition is a picture of its state of affairs, only insofar as it is logically articulated. Even the proposition ambulo is composite, for its stem gives a different sense with another termination, or its termination with another stem. 4.04. In the proposition, there must be exactly as many things distinguishable as there are in the state of affairs which it represents. They must both possess the same logical (mathematical) multiplicity (cf. Hertz Mechanics on Dynamic Models). 4.041. This mathematical multiplicity naturally cannot in its turn be represented. One cannot get outside it in the representation. 4.0411. If we tried, for example, to express what is expressed by (x) end symbol fx by putting an index before fx, like gen fx, it would not do. We should not know what was generalized. If we tried to show it by an index g, like f x subscript g it would not do. We should not know the scope of the generalization. If we were to try it by introducing a mark in the argument places, like capital G, comma, capital G, close bracket, end symbol, capital F, bracket, capital G, comma, capital G, close bracket, close quote, it would not do. We could not determine the identity of the variables, etc. All these ways of symbolizing are inadequate, because they have not the necessary mathematical multiplicity. 4.0412. For the same reason, the idealist explanation of the seeing of spatial relations through spatial spectacles does not do, because it cannot explain the multiplicity of these relations. 4.05. Reality is compared with the proposition. 4.06. Propositions can be true or false only by being pictures of the reality. 4.061. If one does not observe that propositions have a sense independent of the facts, one can easily believe that true and false are two relations between signs and things signified with equal rights. One could then, for example, say that P signifies in the true way what not symbol P signifies in the false way, etc. 4.062. Can we not make ourselves understood by means of false propositions as hitherto with true ones, so long as we know that they are meant to be false? No, for a proposition is true, if what we assert by means of it is the case, and if by P we mean not symbol P, and what we mean is the case, then P in the new conception is true and not false. 4.0621. That, however, the signs P and not symbol P can say the same thing is important, for it shows that the sign not symbol corresponds to nothing in reality. That negation occurs in a proposition is no characteristic of its sense, not symbol P equals P, close bracket. The proposition P and not symbol P have opposite senses, but to them corresponds one and the same reality. 4.063. An illustration to explain the concept of truth. A black spot on white paper. The form of the spot can be described by saying of each point of the plane whether it is white or black. To the fact that a point is black corresponds a positive fact. To the fact that a point is white not black, close bracket, a negative fact. If I indicate a point of the plane a truth value in Frege's terminology, close bracket, this corresponds to the assumption proposed for judgment, etc., etc. But to be able to say that a point is black or white, I must first know under what conditions a point is called white or black, in order to be able to say P is true, or false, close bracket. I must have determined under what conditions I call P true, and thereby I determine the sense of the proposition. The point at which the simile breaks down is this. We can indicate a point on the paper without knowing what white and black are. But to a proposition without a sense corresponds nothing at all, for it signifies no thing, truth value, close bracket, whose properties are called false or true. The verb of the proposition is not is true or is false, as Frege thought, but that which is true must already contain the verb. 4.064. Every proposition must already have a sense. Assertion cannot give it a sense, for what it asserts is the sense itself, and the same holds of denial, etc. 4.0641. One could say the denial is already related to the logical place determined by the proposition that is denied. The denying proposition determines a logical place other than does the proposition denied. The denying proposition determines a logical place with the help of the logical place of the proposition denied, by saying that it lies outside the latter place. That one can deny again the denied proposition shows that what is denied is already a proposition and not merely the preliminary to a proposition. 4.1. A proposition presents the existence and non-existence of atomic facts. 4.11. The totality of true propositions is the total natural science, or the totality of the natural sciences, close bracket. 4.111. Philosophy is not one of the natural sciences, the word, philosophy, must mean something which stands above or below, but not beside the natural sciences, close bracket. 4.112. The object of philosophy is the logical clarification of thoughts. Philosophy is not a theory, but an activity. A philosophical work consists essentially of elucidations. The result of philosophy is not a number of philosophical propositions, but to make propositions clear. Philosophy should make clear and delimit sharply the thoughts which otherwise are, as it were, opaque and blurred. 4.1121. Psychology is no nearer related to philosophy than is any other natural science. The theory of knowledge is the philosophy of psychology. Does not my study of sign language correspond to the study of thought processes which philosophers held to be so essential to the philosophy of logic? Only they got entangled for the most part in unessential psychological investigations, and there is an analogous danger for my method. 4.1122. The Darwinian theory has no more to do with philosophy than has any other hypothesis of natural science. 4.113. Philosophy limits the disputable sphere of natural science. 4.114. It should limit the thinkable, and thereby the unthinkable. It should limit the unthinkable from within through the thinkable. 4.115. It will mean the unspeakable by clearly displaying the speakable. 4.116. Everything that can be thought at all can be thought clearly. Everything that can be said clearly. 4.12. Propositions can represent the whole reality, but they cannot represent what they must have in common with reality in order to be able to represent it. The logical form. To be able to represent the logical form, we should have to be able to put ourselves with the propositions outside logic, that is, outside the world. 4.121. Propositions cannot represent the logical form. This mirrors itself in the propositions. That which mirrors itself in language, language cannot represent. That which expresses itself in language, we cannot express by language. The propositions show the logical form of reality. They exhibit it. 4.1211. Thus a proposition, FA, shows that in its sense the object A occurs. Two propositions, FA and GA, that they are both about the same object. If two propositions contradict one another, this is shown by their structure. Similarly, if one follows from another, etc. 4.1212. What can be shown cannot be said. 4.1213. Now we understand our feeling that we are in possession of the right logical conception, if only all is right in our symbolism. 4.122. We can speak in a certain sense of formal properties of objects and atomic facts, or of properties of the structure of facts, and in the same sense of formal relations, and relations of structures. Instead of property of the structure, I also say, internal property, instead of relation of structures, internal relation, I introduce these expressions in order to show the reason for the confusion, very widespread among philosophers, between internal relations and proper external relations. The holding of such internal properties and relations cannot, however, be asserted by propositions, but it shows itself in the propositions, which present the facts and treat of the objects in question. 4.1221. An internal property of a fact we also call a feature of this fact, in the sense in which we speak of facial features, 4.123. A property is internal if it is unthinkable that its object does not possess it. This bright blue color and that stand in the internal relation of bright and darker, eo ipso. It is unthinkable that these two objects should not stand in this relation. Here, to the shifting use of the words property and relation, there corresponds the shifting use of the word object. 4.124. The existence of an internal property of a possible state of affairs is not expressed by a proposition, but it expresses itself in the proposition which presents that state of affairs by an internal property of this proposition. It would be as senseless to ascribe a formal property to a proposition as to deny it the formal property. 4.1241. One cannot distinguish forms from one another by saying that one has this property, the other that, for this assumes that there is a sense in asserting either property of either form. 4.125. The existence of an internal relation between possible states of affairs expresses itself in language by an internal relation between the propositions presenting them. 4.1251. Now this settles the disputed question, whether all relations are internal or external. Close quote. 4.1252. Series which are ordered by internal relations I call formal series. The series of numbers is ordered not by an external, but by an internal relation. Similarly, the series of propositions, A R B, bracket, there exists X, close bracket, colon, A R X, and symbol, X R B, close quote. Bracket, there exists X, Y, close bracket, colon, A R X, end symbol, X R Y, end symbol, Y R B, close quote, etc. Bracket, if B stands in one of these relations to A, I call B a successor of A, close bracket. 4.126. In the sense in which we speak of formal properties, we can now speak also of formal concepts. Bracket, I introduce this expression in order to make clear the confusion of formal concepts with proper concepts which run through the whole of the old logic. Close bracket. That anything falls under a formal concept as an object belonging to it cannot be expressed by a proposition, but it is shown in the symbol for the object itself. Bracket, the name shows that it signifies an object, the numerical sign that it signifies a number, etc. Close bracket. Formal concepts cannot, like proper concepts, be presented by a function, for their characteristics, the formal properties, are not expressed by the functions. The expression of a formal property is a feature of certain symbols. The sign that signifies the characteristic of a formal concept is, therefore, a characteristic feature of all symbols, whose meanings fall under the concept. The expression of the formal concept is therefore a propositional variable, in which only this characteristic feature is constant. 4.127. The propositional variable signifies the formal concept, and its values signify the objects which fall under this concept. 4.1271. Every variable is the sign of a formal concept, for every variable presents a constant form which all its values possess, and which can be conceived as a formal property of these values. 4.1272. So the variable name, x, is the proper sign of the pseudo-concept object. Wherever the word object, bracket, thing, entity, etc., close bracket, is rightly used, it is expressed in logical symbolism by the variable name. For example, in the proposition, there are two objects which, by, bracket, there exists x, y, close bracket, close quote. Wherever it is used otherwise, in essence as a proper concept word, there arise senseless pseudo-propositions. So one cannot, for example, say, there are objects, close quote, as one says, there are books, close quote, nor, there are 100 objects, close quote, or, there are aleph subscript 0 objects, close quote. And it is senseless to speak of the number of all objects. The same holds of the words, complex, fact, function, number, etc. They all signify formal concepts and are presented in logical symbolism by variables, not by functions or classes, bracket, as Frege and Russell thought, close bracket. Expressions like, one is a number, close quote, there is only one number not, close quote, and all like them are senseless. Bracket, it is as senseless to say, there is only one, close quote, as it would be to say, 2 plus 2 is at 3 o'clock equal to 4, close bracket. 4.12721. The formal concept is already given with an object, which falls under it. One cannot, therefore, introduce both the objects which fall under a formal concept and the formal concept itself, as primitive ideas. One cannot, therefore, e.g. introduce (as Russell does) the concept of function and also special functions as primitive ideas, or the concept of number and definite numbers. 4.1273. If we want to express in logical symbolism the general proposition, B is a successor of A, we need for this an expression for the general term of the formal series, A RB, bracket, there exists X, colon, A R X, end symbol, X RB, bracket, there exists X, Y, close bracket, colon, A R X, end symbol, X RY, end symbol, Y RB. The general term of a formal series can only be expressed by a variable, for the concept symbolized by term of this formal series is a formal concept. This Frege and Russell overlooked. The way in which they express general propositions like the above is, therefore, false. It contains a vicious circle. We can determine the general term of the formal series by giving its first term and the general form of the operation, which generates the following term out of the preceding proposition. 4.1274. The question about the existence of a formal concept is senseless, for no proposition can answer such a question. For example, one cannot ask, are there unanalyzable subject-predicate propositions? 4.128. The logical forms are anumerical. Therefore, there are in logic no preeminent numbers, and therefore there is no philosophical monism or dualism, etc. 4.2. The sense of a proposition is its agreement and disagreement with the possibilities of the existence and non-existence of the atomic facts. 4.21. The simplest proposition, the elementary proposition, asserts the existence of an atomic fact. 4.211. It is a sign of an elementary proposition that no elementary proposition can contradict it. 4.22. The elementary proposition consists of names. It is a connection, a concatenation of names. 4.221. It is obvious that in the analysis of propositions, we must come to elementary propositions, which consists of names in immediate combination. The question arises here, how the propositional connection comes to be. 4.2211. Even if the world is infinitely complex, so that every fact consists of an infinite number of atomic facts, and every atomic fact is composed of an infinite number of objects, even then there must be objects and atomic facts. 4.23. The name occurs in the proposition only in the context of the elementary proposition. 4.24. The names are the simple symbols. I indicate them by single letters, X, Y, Z, close bracket. The elementary proposition I write as a function of the names in the form fx, phi x, y, close bracket, close quotes, etc. Or I indicate it by the letters P, Q, R. 4.241. If I use two signs with one and the same meaning, I express this by putting between them the sign equal symbol. A equals symbol B, close quote, means then that the sign A is replaceable by the sign B. Bracket. If I introduce by an equation a new sign, B, by determining that it shall replace a previously known sign, A, I write the equation, definition, bracket, like Russell, close bracket, in the form, A equals symbol B, def, close quote. A definition is a symbolic rule, close bracket. 4.242. Expressions of the form, A equals symbol B, close quote, are therefore only expedients in presentation. They assert nothing about the meaning of the signs, A and B. 4.243. Can we understand two names without knowing whether they signify the same thing or two different things? Can we understand a proposition in which two names occur without knowing if they mean the same or different things? If I know the meaning of an English and a synonymous German word, it is impossible for me not to know that they are synonymous. It is impossible for me not to be able to translate them into one another. Expressions like, A equals symbol A, close quote, or expressions deduced from these are neither elementary propositions nor otherwise significant signs. Bracket, this will be shown later, close bracket. 4.25. If the elementary proposition is true, the atomic fact exists. If it is false, the atomic fact does not exist. 4.26. The specification of all true elementary propositions describes the world completely. The world is completely described by the specification of all elementary propositions, plus the specification, which of them are true and which false. 4.27. With regard to the existence of n atomic facts, there are K, subscript n, equals sign, small n over sigma over small v equals sign 0, bracket n over v, close bracket, possibilities. It is possible for all combinations of atomic facts to exist, and the others not to exist. 4.28. To these combinations correspond the same number of possibilities of the truth and falsehood of n elementary propositions. 4.3. The truth possibilities of the elementary propositions mean the possibilities of the existence and non-existence of the atomic facts. 4.31. The truth possibilities can be presented by schemata of the following kind, bracket, T means, true, F, false. The rows of T's and F's under the row of the elementary propositions mean their truth possibilities in an easily intelligible symbolism. Reader's note. This table consists of 3 columns. P, Q, R. T, T, T. F, T, T. T, F, T. T, T, F. F, F, T. F, T, F. T, F, F. F, F, F. Reader's note. This truth table consists of 2 columns. P, Q. T, T. F, T. T, F. F, F. Reader's note. This truth table consists of 1 column. P, T, F. 4.4. A proposition is the expression of agreement and disagreement with the truth possibilities of the elementary propositions. 4.41. The truth possibilities of the elementary propositions are the conditions of the truth and falsehood of the propositions. 4.411. It seems probable, even at first sight, that the introduction of the elementary propositions is fundamental for the comprehension of the other kinds of propositions. Indeed, the comprehension of the general propositions depends palpably on that of the elementary propositions. 4.42. With regard to the agreement and disagreement of a proposition with the truth possibilities of n elementary propositions, there are K subscript n over sigma over kappa equals 0, bracket K subscript n over kappa, close bracket, equals L subscript n possibilities. 4.43. Agreement with the truth possibilities can be expressed by coordinating with them in the scheme the mark T, bracket, true, close bracket. Absence of this mark means disagreement. 4.431. The expression of the agreement and disagreement with the truth possibilities of the elementary propositions expresses the truth conditions of the proposition. The proposition is the expression of its truth conditions. Bracket. Frege has therefore quite rightly put them at the beginning, as explaining the signs of his logical symbolism. Only Frege's explanation of the truth concept is false, if the true and the false were real objects, and the arguments in not symbol P, etc., then the sense of not symbol P would by no means be determined by Frege's determination. 4.44. The sign which arises from the coordination of that mark T with the truth possibilities is a propositional sign. 4.441. It is clear that to the complex of the signs F and T, no object, bracket, or a complex of objects, close bracket, corresponds, any more than to horizontal and vertical lines, or to brackets. There are no logical objects, close quote. Something analogous holds of course for all signs, which express the same as the schemata of T and F. 4.442. Thus, for example, reader's note, the truth table consists of 3 columns. P, Q, T, 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 F, T, 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 F, blank, F, F, T, is a propositional sign. Bracket, Frege's assertion sign, inference symbol, close quote, is logically altogether meaningless. In Frege, bracket, and Russell, close bracket, it only shows that these authors hold as true the propositions marked in this way. Inference symbol belongs therefore to the propositions no more than does the number of the proposition. A proposition cannot possibly assert of itself that it is true. If the sequence of the truth possibilities in the scheme is once for all determined by a rule of combination, then the last column is by itself an expression of the truth conditions. If we write this column as a row, the propositional sign becomes bracket, T, T, hyphen, T, close bracket, bracket, P, comma, Q, close bracket, close quote. Or more plainly, bracket, T, T, F, T, close bracket, bracket, P, comma, Q, close bracket, close quote. The number of places in the left-hand bracket is determined by the number of terms in the right-hand bracket, close bracket. 4.45. For n elementary propositions, there are L subscript n possible groups of truth conditions. The groups of truth conditions which belong to the truth possibilities of a number of elementary propositions can be ordered in a series. 4.46. Among the possible groups of truth conditions there are two extreme cases. In the one case, the proposition is true for all the truth possibilities of the elementary propositions. We say that the truth conditions are tautological. In the second case, the proposition is false for all the truth possibilities. The truth conditions are self-contradictory. In the first case, we call the proposition a tautology. In the second case, a contradiction. 4.461. The proposition shows what it says. The tautology and the contradiction that they say nothing. The tautology has no truth conditions, for it is unconditionally true, and the contradiction is on no condition true. Tautology and contradiction are without sense, bracket, like the point from which two arrows go out in opposite directions, close bracket. Bracket, I know, for example, nothing about the weather, when I know that it rains or does not rain, close bracket. 4.4611. Tautology and contradiction are, however, not nonsensical. They are part of the symbolism, in the same way that, quotes, 0 is part of the symbolism of arithmetic. 4.462. Tautology and contradiction are not pictures of the reality. They present no possible state of affairs, for the one allows every possible state of affairs, the other none. In the tautology, the conditions of agreement with the world, the presenting relations, cancel one another, so that it stands in no presenting relation to reality. 4.463. The truth conditions determine the range, which is left to the facts by the proposition. Bracket, the proposition, the picture, the model, are in a negative sense like a solid body, which restricts the free movement of another. In a positive sense, like the space limited by solid substance, in which a body may be placed. Close bracket. Tautology leaves to reality the whole infinite logical space. Contradiction fills the whole logical space and leaves no point to reality. Neither of them, therefore, can in any way determine reality. 4.464. The truth of tautology is certain. Of propositions, possible. Of contradiction, impossible. Bracket, certain, possible, impossible. Here we have an indication of that gradation which we need in the theory of probability. Close bracket. 4.465. The logical product of a tautology and a proposition says the same as the proposition. Therefore, that product is identical with the proposition, for the essence of the symbol cannot be altered without altering its sense. 4.466. To a definite logical combination of signs corresponds a definite logical combination of their meanings. Every arbitrary combination only corresponds to the unconnected signs. That is, propositions which are true for every state of affairs cannot be combinations of signs at all, for otherwise there could only correspond to them definite combinations of objects, bracket, and to no logical combination corresponds no combination of the objects, close bracket. Tautology and contradiction are the limiting cases of the combination of symbols, namely their dissolution. 4.4661. Of course, the signs are also combined with one another in the tautology and contradiction. In essence, they stand in relation to one another, but these relations are meaningless, unessential to the symbol. 4.5. Now, it appears to be possible to give the most general form of proposition, i.e., to give a description of the propositions of some one sign language, so that every possible sense can be expressed by a symbol which falls under the description, and so that every symbol which falls under the description can express a sense, if the meanings of the names are chosen accordingly. It is clear that, in the description of the most general form of proposition, only what is essential to it may be described, otherwise it would not be the most general form. that there is a general form is proved by the fact that there cannot be a proposition whose form could not have been foreseen (i.e. constructed). The general form of proposition is, such and such is the case. 4.51. Suppose all elementary propositions were given me. Then we can simply ask, what propositions I can build out of them? And these are all propositions, and so they are limited. 4.52. The propositions are everything which follows from the totality of all elementary propositions, of course also from the fact that it is the totality of them all, so in some sense one could say that all propositions are generalizations of the elementary propositions. 4.53. The general proposition form is a variable. End of section 2. Recording by Jeffrey Edwards. Of Tractatus Logico-Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C. K. Ogden. Section 3. 5. Propositions are truth functions of elementary propositions. An elementary proposition is a truth function of itself. 5.01. The elementary propositions are the truth arguments of propositions. 5.02. It is natural to confuse the arguments of functions with the indices of names. For I recognize the meaning of the sign containing it from the argument just as much as from the index. In Russell's plus subscript c, for example, c is an index which indicates that the whole sign is the addition sign for cardinal numbers. But this way of symbolizing depends on arbitrary agreement, and could choose a simple sign instead of plus subscript c. But in not symbol p, p is not an index but an argument. The sense of not symbol p cannot be understood unless the sense of p has previously been understood. In the name Julius Caesar, Julius is an index. The index is always part of a description of the object to whose name we attach it. For example, the Caesar of the Julian gens. The confusion of argument and index is, if I am not mistaken, at the root of Frege's theory of the meaning of propositions and functions. For Frege, the propositions of logic were names, and their arguments the indices of these names. 5.1. The truth functions can be ordered in series. That is the foundation of the theory of probability. 5.101. The truth functions of every number of elementary propositions can be written in a scheme of the following kind. T, 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 close bracket, P, comma, Q, close bracket. Tautology, if P, then P, and if Q, then Q, close bracket. Square bracket, P implies symbol P, and symbol Q implies symbol Q, close square bracket. F, T, 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 close bracket. P, comma, Q, close bracket. In words, not both P and Q. Square bracket, not symbol, bracket, P, and symbol q, close bracket, close square bracket. Bracket t, f, t, t, close bracket. Bracket p, comma, q, close bracket. If q, then p, square bracket, q implies symbol p, close square bracket. Bracket t, t, f, t, close bracket. Bracket p, comma, q, close bracket. If p, then q, square bracket, p implies symbol q, close square bracket. Bracket t, 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 f, close bracket. Bracket p, comma, q, close bracket. P or q, square bracket, p or symbol q, close square bracket. Bracket f, f, t, t, close bracket. Bracket p, comma, q, close bracket. Not q, square bracket, not symbol q, close square bracket. Bracket f, t, f, t, close bracket. Bracket p, comma, q, close bracket. Not p, square bracket, not symbol p, close square bracket. Bracket f, t, t, f, close bracket. Bracket p, comma, q, close bracket. P or q, but not both. Square bracket p and symbol, not symbol q, colon or symbol, colon, q and symbol, not symbol p, close square bracket. Bracket t, f, f, t, close bracket. Bracket p, comma, q, close bracket. If p, then q, and if q, then p. Square bracket p, if and only if symbol, q, close square bracket. Bracket t, f, t, f, close bracket. Bracket p, comma, q, close bracket. P. Bracket t, t, f, f, close bracket. Bracket p, comma, q, close bracket. Q. Bracket f, 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 t, close bracket. Bracket p, comma, q, close bracket. Neither p nor q. Square bracket p and symbol, not symbol q, or p, neither nor symbol q, close square bracket. Bracket f, f, t, f, close bracket. Bracket p, comma, q, close bracket. P and not q. Square bracket p and symbol, not symbol q, close square bracket. Bracket f, t, f, f, close bracket. Bracket p, comma, q, close bracket. Q and not P. Square bracket. Q and symbol, not symbol, P. Close square bracket. Bracket. T, F, F, F. Close bracket. Bracket. P, comma, Q. Close bracket. P and Q. Square bracket. P and symbol Q. Close square bracket. Bracket. F, 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 F. Close bracket. Bracket. P, comma, Q. Close bracket. Contradiction. Bracket. P and not P, and Q and not Q. Close bracket. Square bracket. P and symbol, not symbol, P. And symbol, Q. And symbol, not symbol, Q. Close square bracket. Those truth possibilities of its truth arguments, which verify the proposition, I shall call its truth grounds. 5.11. If the truth grounds which are common to a number of propositions are all also truth grounds of some one proposition, we say that the truth of this proposition follows from the truth of those propositions. 5.12. In particular, the truth of a proposition P follows from that of a proposition Q, if all the truth grounds of the second are truth grounds of the first. 5.121. The truth grounds of Q are contained in those of P. P follows from Q. 5.122. If P follows from Q, the sense of P is contained in that of Q. 5.123. If a God creates a world in which certain propositions are true, he creates thereby also a world in which all propositions consequent on them are true. And similarly, he could not create a world in which the proposition P is true without creating all its objects. 5.124. A proposition asserts every proposition which follows from it. 5.1241. P and symbol Q, close quote, is one of the propositions which assert P, and at the same time one of the propositions which assert Q. Two propositions are opposed to one another if there is no significant proposition which asserts them both. Every proposition which contradicts another denies it. 5.13. That the truth of one proposition follows from the truth of other propositions, we perceive from the structure of the propositions. 5.131. If the truth of one proposition follows from the truth of others, this expresses itself in relations in which the forms of these propositions stand to one another, and we do not need to put them in these relations first by connecting them with one another in a proposition, for these relations are internal, and exist as soon as, and by the very fact that, the propositions exist. 5.1311. When we conclude from P or symbol Q and not symbol P to Q, the relation between the forms of the propositions P or symbol Q, close quote, and not symbol P, is here concealed by the method of symbolizing. But if we write, for example, instead of P or symbol Q, close quote, P neither nor symbol Q, and symbol neither nor symbol, and symbol, P neither nor symbol Q, close quote, and instead of not symbol P, P neither nor symbol P, close quote, bracket, P neither nor symbol Q equals neither P nor Q, close bracket. Then the interconnection becomes obvious. Bracket. The fact that we can infer FA from bracket X, close bracket, end symbol fx, shows that generality is present also in the symbol quote bracket x close bracket end symbol fx close quote close bracket. 5.132. If P follows from Q, I can conclude from Q to P, infer P from Q. The method of inference is to be understood from the two propositions alone. Only they themselves can justify the inference. Laws of inference, which, as in Frege and Russell, are to justify the conclusions, are senseless and would be superfluous. 5.133. All inference takes place a priori. 5.134. From an elementary proposition, no other can be inferred. 5.135. In no way can an inference be made from the existence of one state of affairs to the existence of another entirely different from it. 5.136. There is no causal nexus which justifies such an inference. 5.1361. The events of the future cannot be inferred from those of the present. Superstition is the belief in the causal nexus. 5.1362. The freedom of the will consists in the fact that future actions cannot be known now. We could only know them if causality were an inner necessity, like that of logical deduction. The connection of knowledge and what is known is that of logical necessity. Bracket, quote, A knows that P is the case, close quote, is senseless if P is a tautology, close bracket. 5.1363. If from the fact that a proposition is obvious to us, it does not follow that it is true, then obviousness is no justification for our belief in its truth. 5.14. If a proposition follows from another, then the latter says more than the former less than the latter. 5.141. If P follows from Q, and Q from P, then they are one and the same proposition. 5.142. A tautology follows from all propositions. It says nothing. 5.143. Contradiction is something shared by propositions, which no proposition has in common with another. Tautology is that which is shared by all propositions, which have nothing in common with one another. Contradiction vanishes, so to speak, outside. Tautology inside all propositions. Contradiction is the eternal limit of the propositions. Tautology their substanceless center. 5.15. If T subscript R is the number of the truth grounds of the proposition quotes R, T subscript RS, the number of those truth grounds of the proposition quotes S, which are at the same time truth grounds of quotes R, then we call the ratio T subscript RS colon T subscript R, the measure of the probability which the proposition quotes R gives to the proposition quotes S. 5.151. Suppose in a schema like that above in number 5.101, T subscript R is the number of the quotes capital T's in the proposition R, T subscript RS, the number of those quotes capital T's in the proposition S, which stands in the same columns as quotes capital T's of the proposition R, then the proposition R gives to the proposition S the probability T subscript RS colon T subscript R. 5.1511. There is no special object peculiar to probability propositions. 5.152. Propositions which have no truth arguments in common with one another we call independent. Two elementary propositions give to one another the probability 1/2. If P follows from Q, the proposition Q gives to the proposition P the probability 1. The certainty of logical conclusion is a limiting case of probability (application to tautology and contradiction). 5.153. A proposition is in itself neither probable nor improbable. An event occurs or does not occur. There is no middle course. 5.154. In an urn there are equal numbers of white and black balls (and no others). I draw one ball after another and put them back in the urn. Then I can determine by the experiment that the numbers of the black and white balls which are drawn approximate as the drawing continues. So this is not a mathematical fact. If then, I say, it is equally probable that I should draw a white and a black ball, this means, all the circumstances known to me (including the natural laws hypothetically assumed), give to the occurrence of the one event no more probability than to the occurrence of the other. That is, they give, as can easily be understood from the above explanations, to each the probability 1/2. What I can verify by the experiment is that the occurrence of the two events is independent of the circumstances with which I have no closer acquaintance. 5.155. The unit of the probability proposition is the circumstances with which I am not further acquainted give to the occurrence of a definite event such and such a degree of probability. 5.156. Probability is a generalization. It involves a general description of a propositional form. Only in default of certainty do we need probability. If we are not completely acquainted with a fact, but know something about its form (a proposition can, indeed, be an incomplete picture of a certain state of affairs, but it is always a complete picture), the probability proposition is, as it were, an extract from other propositions. 5.2. The structures of propositions stand to one another in internal relations. 5.21. We can bring out these internal relations in our manner of expression, by presenting a proposition as the result of an operation which produces it from other propositions (the bases of the operation). 5.22. The operation is the expression of a relation between the structures of its result and its bases. 5.23. The operation is that which must happen to a proposition in order to make another out of it. 5.231. And that will naturally depend on their formal properties, on the internal similarity of their forms. 5.232. The internal relation which orders a series is equivalent to the operation by which one term arises from another. 5.233. The first place in which an operation can occur is where a proposition arises from another in a logically significant way, in essence, where the logical construction of the proposition begins. 5.234. The truth functions of elementary propositions are results of operations which have the elementary propositions as bases. I call these operations truth operations. 5.2341. The sense of a truth function of P is a function of the sense of P. Denial, logical addition, logical multiplication, etc., etc. are operations. Denial reverses the sense of a proposition. 5.24. An operation shows itself in a variable. It shows how we can proceed from one form of proposition to another. It gives expression to the difference between the forms, and that which is common to the bases and the result of an operation is the bases themselves. 5.241. The operation does not characterize a form, but only the difference between forms. 5.242. The same operation which makes Q from P makes R from Q, and so on. This can only be expressed by the fact that P, Q, R, etc. are variables which give general expression to certain formal relations. 5.25. The occurrence of an operation does not characterize the sense of a proposition, for an operation does not assert anything, only its result does, and this depends on the basis of the operation. Operation and function must not be confused with one another. 5.251. A function cannot be its own argument, but the result of an operation can be its own basis. 5.252. Only in this way is the progress from term to term in a formal series possible, from type to type in the hierarchy of Russell and Whitehead, Russell and Whitehead have not admitted the possibility of this progress, but have made use of it all the same. 5.2521. The repeated application of an operation to its own result I call its successive application. Capital O prime, capital O prime, capital O prime, A, close quote, is the result of the threefold successive application of capital O prime, close quote, to A, close bracket. In a similar sense, I speak of the successive application of several operations to a number of propositions. 5.2522. The general term of the formal series A, capital O prime A, capital O prime, capital O prime A, I write thus, square bracket A, X, capital O prime X, close square bracket, close quote. This expression in brackets is a variable. The first term of the expression is the beginning of the formal series, the second the form of an arbitrary term x of the series, and the third the form of that term of the series which immediately follows x. 5.2523. The concept of the successive application of an operation is equivalent to the concept and so on, 5.253. One operation can reverse the effect of another. Operations can cancel one another. 5.254. Operations can vanish, for example, denial in not symbol, P, end symbol, not symbol, P, equals P, close bracket. 5.3. All propositions are results of truth operations on the elementary propositions. The truth operation is the way in which a truth function arises from elementary propositions. According to the nature of truth operations, in the same way as out of elementary propositions arise their truth functions. From truth functions arise a new one. Every truth operation creates from truth functions of elementary propositions another truth function of elementary propositions, in essence a proposition. The result of every truth operation on the results of truth operations on elementary propositions is also the result of one truth operation on elementary propositions. Every proposition is the result of truth operations on elementary propositions. 5.31. The schemata number 4.31 are also significant if P, Q, R, etc. are not elementary propositions, and it is easy to see that the propositional sign in number 4.42 expresses one truth function of elementary propositions even when P and Q are truth functions of elementary propositions. 5.32. All truth functions are results of the successive application of a finite number of truth operations to elementary propositions. 5.4. Here it becomes clear that there are no such things as logical objects, or logical constants, bracket, in the sense of Frege and Russell, close bracket. 5.41. For all those results of truth operations on truth functions are identical, which are one and the same truth function of elementary propositions. 5.42. That or symbol, implies symbol, etc. are not relations in the sense of right and left, etc. is obvious. The possibility of crosswise definition of the logical primitive signs of Frege and Russell shows by itself that these are not primitive signs, and that they signify no relations. And it is obvious that the implies symbol, which we define by means of not symbol and or symbol, is identical with that by which we define or symbol with the help of not symbol, and that this or symbol is the same as the first, and so on. 5.43. That from a fact P an infinite number of others should follow, namely not symbol P, not symbol P, etc., is indeed hardly to be believed, and it is no less wonderful that the infinite number of propositions of logic (of mathematics) should follow from half a dozen primitive propositions. But the propositions of logic say the same thing, that is, nothing. 5.44. Truth functions are not material functions. If, for example, an affirmation can be produced by repeated denial, is the denial in any sense contained in the affirmation? Does not symbol P deny not symbol P? Or does it affirm P, or both? The proposition not symbol P does not treat of denial as an object, but the possibility of denial is already prejudged in affirmation. And if there was an object called not symbol, then not symbol P would have to say something other than P. For the one proposition would then treat of not symbol, the other would not. 5.441. This disappearance of the apparent logical constants also occurs if, not symbol, there exists symbol x, close bracket, and symbol, not symbol fx, close quote, says the same as, x, close bracket, and symbol fx, close quote. Or, there exists symbol x, close bracket, and symbol fx, and symbol x equals a, close quote. The same as, fa, close quote. 5.442. If a proposition is given to us, then the results of all truth operations which have it as their basis are given with it. 5.45. If there are logical primitive signs, a correct logic must make clear their position relative to one another and justify their existence. The construction of logic out of its primitive signs must become clear. 5.451. If logic has primitive ideas, these must be independent of one another. If a primitive idea is introduced, it must be introduced in all contexts in which it occurs at all. One cannot, therefore, introduce it for one context and then again for another. For example, if denial is introduced, we must understand it in propositions of the form, not symbol P, just as in propositions like, not symbol, P, or symbol Q, close bracket, there exists symbol x, close bracket, and symbol, not symbol, f, x, and others. We may not first introduce it for one class of cases, and then for another, for it would then remain doubtful whether its meaning in the two cases was the same, and there would be no reason to use the same way of symbolizing in the two cases. In short, what Frege Grundgesetze der Arithmetik has said about the introduction of signs by definitions holds, mutatis mutandis, for the introduction of primitive signs also. 5.452. The introduction of a new expedient in the symbolism of logic must always be an event full of consequences. No new symbol may be introduced in logic in brackets or in the margin, with, so to speak, an entirely innocent face. Thus in the Principia Mathematica of Russell and Whitehead, there occur definitions and primitive propositions in words. Why suddenly words here? This would need a justification. There was none and can be none, for the process is actually not allowed. But if the introduction of a new expedient has proved necessary in one place, we must immediately ask, where is this expedient always to be used? Its position in logic must be made clear. 5.453. All numbers in logic must be capable of justification. Or rather, it must become plain that there are no numbers in logic. There are no preeminent numbers. 5.454. In logic, there is no side-by-side. There can be no classification. In logic, there cannot be a more general and a more special. 5.4541. The solution of logical problems must be neat, for they set the standard of neatness. Men have always thought that there must be a sphere of questions whose answers, a priori, are symmetrical and united into a closed regular structure, a sphere in which the proposition, simplex sigillum veri, is valid. 5.46. When we have rightly introduced the logical signs, the sense of all their combinations has been already introduced with them. Therefore, not only P or symbol Q, but also not symbol bracket P or symbol not symbol Q, etc., etc. We should then already have introduced the effect of all possible combinations of brackets. And it would then have become clear that the proper general primitive signs are not P or symbol Q, bracket, there exists symbol X, N symbol F, X, etc., but the most general form of their combinations. 5.461. The apparently unimportant fact that the apparent relations like or symbol and imply symbol need brackets, unlike real relations, is of great importance. The use of brackets with these apparent primitive signs shows that these are not the real primitive signs, and nobody of course would believe that the brackets have meaning by themselves. 5.4611. Logical operation signs are punctuations. 5.47. It is clear that everything which can be said beforehand about the form of all propositions at all can be said on one occasion. For all logical operations are already contained in the elementary proposition. For fa says the same as bracket, there exists symbol x, and symbol fx, and symbol x equals a, Where there is a composition, there is argument and function, and where these are, all logical constants already are. One could say, the one logical constant is that which all propositions, according to their nature, have in common with one another. That, however, is the general form of proposition. 5.471. The general form of proposition is the essence of proposition. 5.4711. To give the essence of proposition means to give the essence of all description, therefore the essence of the world. 5.472. The description of the most general propositional form is the description of the one and only general primitive sign in logic. 5.473. Logic must take care of itself. A possible sign must also be able to signify. Everything which is possible in logic is also permitted. Bracket, quote, Socrates is identical, close quote, means nothing because there is no property which is called, quotes, identical. The proposition is senseless because we have not made some arbitrary determination, not because the symbol is itself unpermissible, close bracket. In a certain sense, we cannot make mistakes in logic. 5.4731. Self-evidence, of which Russell has said so much, can only be discarded in logic by language itself preventing every logical mistake. That logic is a priori consists in the fact that we cannot think illogically. 5.4732. We cannot give a sign the wrong sense. 5.47321. Occam's razor is, of course, not an arbitrary rule, nor one justified by its practical success. It simply says that unnecessary elements in a symbolism mean nothing. Signs which serve one purpose are logically equivalent. Signs which serve no purpose are logically meaningless. 5.4733. Frege says, every legitimately constructed proposition must have a sense. And I say, every possible proposition is legitimately constructed, and if it has no sense, this can only be because we have given no meaning to some of its constituent parts. Bracket, even if we believe that we have done so, close bracket. Thus, quote, Socrates is identical, close quote, says nothing, because we have given no meaning to the word, quotes, identical, as adjective. For when it occurs as the sign of equality, it symbolizes in an entirely different way. The symbolizing relation is another. Therefore, the symbol is in the two cases entirely different. The two symbols have the sign in common with one another only by accident. 5.474. The number of necessary fundamental operations depends only on our notation. 5.475. It is only a question of constructing a system of signs of a definite number of dimensions of a definite mathematical multiplicity. 5.476. It is clear that we are not concerned here with a number of primitive ideas which must be signified, but with the expression of a rule. 5.5. Every truth function is a result of the successive application of the operation. Bracket, dash, 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 capital T, close bracket, bracket, xi, comma, dot, 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 close bracket, to elementary propositions. This operation denies all the propositions in the right-hand bracket, and I call it the negation of these propositions. 5.501. An expression in brackets whose terms are propositions I indicate, if the order of the terms in the brackets is indifferent, by a sign of the form, quotes, bracket, line over xi, close bracket, close quote. Quotes, xi is a variable whose values are the terms of the expression in brackets, and the line over the variable indicates that it stands for all its values in the bracket. Bracket. Thus, if xi has the three values, capital P, capital Q, capital R, then bracket, line over xi, close bracket, equals, bracket, capital P, comma, capital Q, comma, capital R, close bracket. the values of the variables must be determined. The determination is the description of the propositions which the variable stands for. How the description of the terms of the expression in brackets takes place is unessential. We may distinguish three kinds of description. 1. Direct enumeration. In this case, we can place simply its constant values instead of the variable. 2. Giving a function f(x), whose values for all values of x are the propositions to be described. 3. Giving a formal law, according to which those propositions are constructed. In this case, the terms of the expression in brackets are all the terms of a formal series. End of section 3. Recording by Jeffrey Edwards. Of Tractatus Logico-Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C.K. Ogden. Section 4. 5.502. Therefore, I write instead of quote, bracket, dash, 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 capital T, close bracket, bracket, xi, comma, dot, 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 close bracket, close quote, capital N, bracket, line over xi, close bracket, close quote. Capital N, bracket, line over xi, close bracket, is the negation of all the values of the propositional variable xi. 5.503. As it is obviously easy to express how propositions can be constructed by means of this operation, and how propositions are not to be constructed by means of it, this must be capable of exact expression. 5.51. If xi has only one value, then N, bracket, line over xi, close bracket, equals not symbol p, bracket, not p, close bracket. If it has two values, then N, bracket, line over xi, close bracket, equals not symbol p and symbol not symbol q, bracket, neither p nor q, close bracket. 5.511. How can the all-embracing logic which mirrors the world use such special catches and manipulations? Only because all these are connected into an infinitely fine network, to the great mirror. 5.512. Quotes not symbol p is true if quotes p is false. Therefore, in the true proposition, quotes not symbol p, quotes p is a false proposition. How then can the stroke, quotes not symbol, bring it into agreement with reality? That which denies in quotes not symbol p is however not quotes not symbol, but that which all signs of this notation, which deny p, have in common. Hence, the common rule according to which quotes not symbol p, quotes not symbol not symbol not symbol p, quotes not symbol p or symbol not symbol p, quotes not symbol p and symbol not symbol p, etc., etc., bracket to infinity, close bracket, are constructed, and this which is common to them all mirrors denial. 5.513. We could say, what is common to all symbols, which asserts both p and q, is the proposition, quote, p and symbol q, close quote. What is common to all symbols, which asserts either p or q, is the proposition, quote, P or symbol Q, close quote. And similarly, we can say, two propositions are opposed to one another when they have nothing in common with one another, and every proposition has only one negative, because there is only one proposition which lies altogether outside it. Thus, in Russell's notation, also it appears evident that, quote, Q, colon, P, or symbol, not symbol P, close quote, says the same thing as, quotes, Q. That, quote, P, or symbol, not symbol P, close quote, says nothing. 5.514. If a notation is fixed, there is in it a rule according to which all the propositions denying P are constructed. A rule according to which all the propositions asserting P are constructed. A rule according to which all the propositions asserting P or Q are constructed, and so on. These rules are equivalent to the symbols, and in them their sense is mirrored. 5.515. It must be recognized in our symbols that what is connected by quotes or symbol, quotes and symbol, etc. must be propositions. And this is the case for the symbols quotes P and quotes Q presuppose quotes or symbol, quotes not symbol, etc. If the sign quotes P in quote P or symbol Q, close quote, does not stand for a complex sign, then by itself it cannot have sense. But then also the signs quote P or symbol P, close quote, quote P and symbol P, close quote, etc., which have the same sense as quotes P, have no sense. If, however, quote P or symbol P, close quote, has no sense, then also quote P or symbol Q, close quote, can have no sense. 5.5151. Must the sign of the negative proposition be constructed by means of the sign of the positive? Why should one not be able to express the negative proposition by means of a negative fact? Bracket, like, if quotes A does not stand in a certain relation to quotes B, it could express that A capital R B is not the case, close bracket. But here also the negative proposition is indirectly constructed with the positive. The positive proposition must presuppose the existence of the negative proposition, and conversely. 5.52. If the values of xi are the total values of a function, fx, for all values of x, then N bracket line over xi, close bracket, equals, not symbol, bracket, there exists symbol, x, close bracket, and symbol, fx. 5.521. I separate the concept all from the truth function. Frege and Russell have introduced generality in connection with the logical product of the logical sum. Then it would be difficult to understand the propositions, quote, bracket, there exists symbol x, close bracket, and symbol fx, close quote, and, quote, bracket, x, close bracket, and symbol fx, close quote, in which both ideas lie concealed. 5.522. That which is peculiar to the, quote, symbolism of generality, close quote, is firstly, that it refers to a logical prototype, and secondly, that it makes constants prominent. 5.523. The generality symbol occurs as an argument. 5.524. If the objects are given, therewith are all objects also given. If the elementary propositions are given, then therewith all elementary propositions are also given. 5.525. It is not correct to render the proposition, quote, bracket, there exists symbol x, close bracket, and symbol fx, close quote, as Russell does in the words, quote, fx is possible, Close quote. Certainty, possibility, or impossibility of a state of affairs are not expressed by a proposition, but by the fact that an expression is a tautology, a significant proposition, or a contradiction. That precedent to which one must always appeal must be present in the symbol itself. 5.526. One can describe the world completely by completely generalized propositions. In essence, without from the outset coordinating any name with a definite object. In order then to arrive at the customary way of expression, we need simply say after an expression, there is one and only one x which ... close quote, the words, and that x is a, close quote. 5.5261. A completely generalized proposition is like every other proposition composite. Bracket. This is shown by the fact that in bracket there exists symbol x, comma, phi, close bracket, and symbol phi x, close quote. We must mention phi and x separately. Both stand independently in signifying relations to the world as in the ungeneralized proposition. Close bracket. A characteristic of a composite symbol. It has something in common with other symbols. 5.5262. The truth or falsehood of every proposition alters something in the general structure of the world, and the range which is allowed to its structure by the totality of elementary propositions is exactly that which the completely general propositions delimit. Bracket. If an elementary proposition is true, then at any rate there is one more elementary proposition true. Close bracket. 5.53. Identity of the object I express by identity of the sign, and not by means of a sign of identity. Difference of the objects by difference of the signs. 5.5301. That identity is not a relation between objects is obvious. This becomes very clear if, for example, one considers the proposition, bracket, x, close bracket, colon, fx, and symbol, imply symbol, and symbol, x equals a, close quote. What this proposition says is simply that only a satisfies the function f, and not that only such things satisfy the function f which have a certain relation to a. One could of course say that in fact only a has this relation to a, but in order to express this, we should need the sign of identity itself. 5.5302. Russell's definition of equal symbol won't do, because according to it one cannot say that two objects have all their properties in common. Bracket, even if this proposition is never true, it is nevertheless significant. Close bracket. 5.5303. Roughly speaking, to say of two things that they are identical is nonsense, and to say of one thing that it is identical with itself is to say nothing. 5.531. I write therefore not, f bracket a comma b close bracket and symbol a equals b close quote, but f bracket a comma a close bracket close quote, bracket or f bracket b comma b close bracket close quote close bracket, and not f bracket a comma b close bracket and symbol not symbol a equals b close quote, but f bracket a comma b close bracket close quote. 5.532. And analogously, not bracket there exists symbol x comma y close bracket and symbol f bracket x comma y close bracket and symbol x equals y, close quote, but, quote, bracket, there exists symbol x, close bracket, and symbol f, bracket, x, comma, x, close bracket, close quote. And not, quote, bracket, there exists symbol x, comma, y, close bracket, and symbol f, bracket, x, comma, y, close bracket, and symbol, not symbol x equals y, close quote. But, quote, bracket, there exists symbol x, comma, y, close bracket, and symbol f, bracket, x, comma, y, close bracket, close quote. Therefore, instead of Russell's, quote, bracket, there exists symbol x, comma, y, close bracket, and symbol f, bracket, x, comma, y, close bracket, close quote, we get, quote, bracket, there exists symbol x, comma, y, close bracket, and symbol f, bracket, x, comma, y, close bracket, and symbol, or symbol, and symbol, bracket, there exists symbol x, close bracket, and symbol f, bracket, x, comma, x, close bracket, close quote. 5.5321. Instead of, quote, bracket x, close bracket, colon, fx implies symbol x equals a, close quote, we therefore write, for example, quote, bracket, there exists symbol x, close bracket, and symbol fx, and symbol implies symbol, and symbol fa, colon, not symbol, bracket, there exists symbol x, comma, y, close bracket, and symbol fx, and symbol fy, close quote. And if the proposition, quote, only one x satisfies f, bracket, close quote, reads, quote, bracket, there exists symbol x, close bracket, and symbol fx, colon, not symbol, bracket, there exists symbol x, comma, y, close bracket, and symbol fx, and symbol fy, close quote. 5.533. The identity sign is therefore not an essential constituent of logical notation. 5.534. And we see that the apparent propositions like, quote, a equals a, close quote, quote, a equals b, and symbol b equals c, and symbol implies symbol a equals c, close quote, quote, bracket, x, close bracket, and symbol x equals x, close quote, quote, bracket, there exists symbol x, close bracket, and symbol x equals a, close quote, etc. cannot be written in a correct logical notation at all. 5.535. So all such problems disappear which are connected with such pseudo-propositions. This is the place to solve all the problems which arise through Russell's, quote, axiom of infinity, close quote. What the axiom of infinity is meant to say would be expressed in language by the fact that there is an infinite number of names with different meanings. 5.5351. There are certain cases in which one is tempted to use expressions of the form, quote, a equals a, close quote, or, quote, p implies symbol p, close quote, as for instance, when one would speak of the archetype, proposition, thing, etc. So Russell in the Principles of Mathematics has rendered the nonsense, quote, p is a proposition, close quote, in symbols by, quote, p implies symbol p, close quote, and has put it as a hypothesis before certain propositions to show that their places for arguments could only be occupied by propositions. Bracket, it is nonsense to place the hypothesis p implies symbol p before a proposition in order to ensure that its arguments have the right form, because the hypothesis for a non-proposition as argument becomes not false but meaningless, and because the proposition itself becomes senseless for arguments of the wrong kind, and therefore it survives the wrong arguments no better and no worse than the senseless hypothesis attached for this purpose. Close bracket. 5.5352. Similarly, it was proposed to express, quote, there are no things, close quote, by, quote, not symbol, bracket, there exists symbol x, close bracket, and symbol x equals x, close quote. But even if this were a proposition, would it not be true if indeed, quote, there were things, close quote, but these were not identical with themselves? 5.54. In the general propositional form, propositions occur in a proposition only as bases of the truth operations. 5.541. At first sight it appears as if there were also a different way in which one proposition could occur in another, especially in certain propositional forms of psychology like, quote, A thinks that P is the case, close quote, or, quote, A thinks P, close quote, etc. Here it appears superficially as if the proposition P stood to the object A in a kind of relation, bracket, and in modern epistemology, bracket, Russell, Moore, etc., close bracket, those propositions have been conceived in this way, close bracket. 5.542. But it is clear that, quote, A believes that P, close quote, A thinks P, close quote, A says P, close quote, are of the form, quotes P, says P, close quote. And here we have no coordination of a fact and an object, but a coordination of facts by means of a coordination of their objects. 5.5421. This shows that there is no such thing as the soul, the subject, etc., as it is conceived in superficial psychology. A composite soul would not be a soul any longer. 5.5422. The correct explanation of the form of the proposition, quote, A judges P, close quote, must show that it is impossible to judge a nonsense, bracket, Russell's theory does not satisfy this condition, close bracket. 5.5423. To perceive a complex means to perceive that its constituents are combined in such and such a way. Reader's note. A Necker cube is drawn with the top left corner labeled B, the top right corner labeled B, the upper middle left corner labeled A, the upper middle right corner labeled A, the lower middle left corner labeled B, the lower middle right corner labeled B, and the bottom left corner labeled A, and the bottom right corner labeled A. This perhaps explains that the figure can be seen in two ways, as a cube, and all similar phenomena. For we really see two different facts, bracket, if I fix my eyes first on the corners A and only glance at B, A appears in front and B behind, and vice versa, close bracket. 5.55. We must now answer a priori the question as to all possible forms of the elementary propositions. The elementary proposition consists of names. Since we cannot give the number of names with different meanings, we cannot give the composition of the elementary proposition. 5.551. Our fundamental principle is that every question which can be decided at all by logic can be decided offhand, bracket, and if we get into a situation where we need to answer such a problem by looking at the world, this shows that we are on a fundamentally wrong track, close bracket. 5.552. The, quotes, experience which we need to understand logic is not that such and such is the case, but that something is. But that is no experience. Logic precedes every experience, that something is so. It is before the how, not before the what. 5.5521. And if this were not the case, how could we apply logic? We could say, if there were a logic, even if there were no world, how then could there be a logic, since there is a world? 5.553. Russell said that there were simple relations between different numbers of things, individuals, but between what numbers, and how should this be decided? By experience. There is no preeminent number, 5.554. The enumeration of any special forms would be entirely arbitrary. 5.5541. How could we decide a priori whether, for example, I can get into a situation in which I need to symbolize with a sign of a 27-termed relation? 5.5542. May we then ask this at all? Can we set out a sign form and not know whether anything can correspond to it? Has the question sense? What must there be in order that anything can be the case? 5.555. It is clear that we have a concept of the elementary proposition apart from its special logical form. Where, however, we can build symbols according to a system, there this system is the logically important thing, and not the single symbols. And how would it be possible that I should have to deal with forms in logic which I can invent? But I must have to deal with that which makes it possible for me to invent them. 5.556. There cannot be a hierarchy of the forms of the elementary propositions. Only that which we ourselves construct can we foresee. 5.5561. Empirical reality is limited by the totality of objects. The boundary appears again in the totality of elementary propositions. The hierarchies are and must be independent of reality. 5.5562. If we know on purely logical grounds that there must be elementary propositions, then this must be known by everyone who understands propositions in their unanalyzed form. 5.5563. All propositions of our colloquial language are actually, just as they are, logically completely in order. That simple thing which we ought to give here is not a model of the truth, but the complete truth itself. Our problems are not abstract, but perhaps the most concrete that there are. 5.557. The application of logic decides what elementary propositions there are. What lies in its application logic cannot anticipate. It is clear that logic may not conflict with its application, but logic must have contact with its application. Therefore logic and its application may not overlap one another. 5.5571. If I cannot give elementary propositions a priori, then it must lead to obvious nonsense to try to give them. 5.6. The limits of my language means the limits of my world. 5.61. Logic fills the world. The limits of the world are also its limits. We cannot therefore say in logic, this and this there is in the world, that there is not. For the world apparently presupposes that we exclude certain possibilities, and this cannot be the case, since otherwise logic must get outside the limits of the world, that is, if it could consider these limits from the other side also. What we cannot think, that we cannot think. We cannot therefore say what we cannot think. 5.62. This remark provides a key to the question, to what extent solipsism is a truth. In fact, what solipsism means is quite correct, only it cannot be said, but it shows itself. That the world is my world, shows itself in the fact that the limits of the language, the language which I understand, means the limits of my world. 5.621. The world and life are one. 5.63. I am my world, the microcosm, 5.631. The thinking, presenting subject, there is no such thing. If I wrote a book, the world as I found it, I should also have therein to report on my body, and say which members obey my will, and which do not, etc. This then would be a method of isolating the subject, or rather of showing that in an important sense there is no subject. That is to say, of it alone in this book mention could not be made. 5.632. The subject does not belong to the world, but it is a limit of the world. 5.633. Where in the world is a metaphysical subject to be noted? You say that this case is altogether like that of the eye and the field of sight, but you do not really see the eye. And from nothing in the field of sight can it be concluded that it is seen from an eye. 5.6331. For the field of sight has not a form like this. Reader's note. An illustration depicts a chicken egg-shaped oval with a tiny circle representing the eye at the small end of the oval. The eye is inside the oval. End reader's note. 5.634. This is connected with the fact that no part of our experience is also a priori. Everything we see could also be otherwise. Everything we describe at all can also be otherwise. There is no order of things a priori. 5.64. Here we see that solipsism, strictly carried out, coincides with pure realism. The eye in solipsism shrinks to an extensionless point, and there remains the reality coordinated with it. 5.641. There is therefore really a sense in which philosophy can talk of a non-psychological eye. The eye occurs in philosophy through the fact that the quote, world is my world, close quote. The philosophical eye is not the man, not the human body or the human soul of which psychology treats, but the metaphysical subject, the limit, not a part of the world. End of section 4. Recording by Jeffrey Edwards. Section 5 of Tractatus Logico-Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording in memory of Mitchell Edwards. Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C. K. Ogden. Section 5. 6. The general form of truth function is square bracket, line over p, comma, line over xi, comma, capital N, bracket, line over xi, close bracket, close square bracket. This is the general form of proposition. 6.001. This says nothing else than that every proposition is the result of successive applications of the operation N prime, bracket, line over xi, close bracket, to the elementary propositions. 6.002. If we are given the general form of the way in which a proposition is constructed, then thereby we are also given the general form of the way in which, by an operation out of one proposition, another can be created. 6.01. The general form of the operation omega prime, bracket, line over eta, close bracket, is therefore square bracket, line over xi, comma, capital N, bracket, line over xi, close bracket, close square bracket, prime, bracket, line over eta, close bracket, equals symbol, square bracket, line over eta, comma, line over xi, comma, capital N, bracket, line over eta, close bracket, close square bracket, close bracket. This is the most general form of transition from one proposition to another. 6.02. And thus we come to numbers. I define x equals omega superscript 0 prime regular script x def and omega prime, omega superscript v prime, regular script x equals omega superscript v plus 1 prime, regular script x, def. According then to these symbolic rules, we write the series x, comma, omega prime x, comma, omega prime x, comma, omega prime x, dot dot dot. As omega superscript 0 prime, regular script x, comma, omega superscript 0 plus 1 prime, regular script x, comma, omega superscript 0 plus 1 prime, regular script x, comma, omega superscript 0 plus 1 prime, regular script x, dot dot dot. Therefore, I write in place of, quote, square bracket, x, comma, xi, comma, omega prime xi, close square bracket, close quote, quote, square bracket, omega superscript 0, comma, omega superscript v prime, regular script x, comma, omega superscript v plus 1 prime, regular script x, close square bracket, close quote. And I define 0 plus 1 equals 1 def. 0 plus 1 equals 2 def. 0 plus 1 equals 3 def, and so on. 6.021. A number is the exponent of an operation. 6.022. The concept number is nothing else than that which is common to all numbers, the general form of a number. 6.03. The general form of the cardinal number is square bracket 0, comma, xi plus 1, close square bracket. 6.031. The theory of classes is altogether superfluous in mathematics. This is connected with the fact that the generality which we need in mathematics is not the accidental one. 6.1. The propositions of logic are tautologies. 6.11. The propositions of logic therefore say nothing, bracket, they are the analytical propositions, close bracket. 6.111. Theories which make a proposition of logic appear substantial are always false. One could, for example, believe that the words quotes true and quotes false signify two properties among other properties, and then it would appear as a remarkable fact that every proposition possesses one of these properties. This now by no means appears self-evident, no more so than the proposition, quote, all roses are either yellow or red, close quote, would seem even if it were true. Indeed, our proposition now gets quite the character of a proposition of natural science, and this is a certain symptom of its being falsely understood. 6.112. The correct explanation of logical propositions must give them a peculiar position among all propositions. 6.113. It is the characteristic mark of logical propositions that one can perceive in the symbol alone that they are true, and this fact contains in itself the whole philosophy of logic, and so also it is one of the most important facts that the truth or falsehood of non-logical propositions cannot be recognized from the propositions alone. 6.12. The fact that the propositions of logic are tautologies shows the formal, logical properties of language of the world. That its constituent parts connected together in this way give a tautology characterizes the logic of its constituent parts. In order that propositions connected together in a definite way may give a tautology, they must have definite properties of structure. That they give a tautology when so connected, shows therefore that they possess these properties of structure. 6.1201. That, for example, the propositions P and not symbol P in the connection not symbol P and symbol not symbol P give a tautology shows that they contradict one another. That the propositions P implies symbol Q P and Q connected together in the form bracket P implies symbol Q and symbol bracket P colon implies symbol colon bracket Q give a tautology shows that Q follows from P and P implies Q. That bracket X and symbol Fx colon implies symbol colon Fa is a tautology shows that Fa follows from bracket X and symbol Fx etc. 6.1202. It is clear that we could have used for this purpose contradictions instead of tautologies. 6.1203. In order to recognize a tautology as such, we can, in cases in which no sign of generality occurs in the tautology, make use of the following intuitive method. I write instead of P, Q, R, etc. Capital T, P, capital F, capital T, Q, capital F, capital T, R, capital F, etc. The truth combinations I express by brackets. E.g., reader's note. The following is a description of an image. The top horizontal bracket connects the T in capital T, P, capital F to the F in capital T, Q, capital F. The next horizontal bracket connects the T in capital T, P, capital F to the T in capital T, Q, capital F. The next horizontal bracket connects the F in capital T, P, capital F to the T in capital T, Q, capital F. The bottom horizontal bracket connects the F in capital T, P, capital F to the F in capital T, Q, capital F. End of description of image. And the coordination of the truth or falsity of the whole proposition with the truth combinations of the truth arguments by lines in the following way. Reader's note. The following is a description of an image. The top horizontal bracket which connects the T in capital T, P, capital F to the F in capital T, Q, capital F is labeled with an F. The next horizontal bracket which connects the T in capital T, P, capital F to the T in capital T, Q, capital F is labeled with a T. The next horizontal bracket which connects the F in capital T, P, capital F to the T in capital T, Q, capital F is labeled with a T. The bottom horizontal bracket which connects the F in capital T, P, capital F to the F in capital T, Q, capital F is labeled with a T. End of description of image. This sign, for example, would therefore present the proposition P implies symbol Q. Now I will proceed to inquire whether such a proposition as not symbol bracket P and symbol not symbol P close bracket, the law of contradiction close bracket, is a tautology. The form not symbol xi close quote is written in our notation. Reader's note. The following is a description of an image. Capital T, xi, capital F, inside of quotes. The capital T in the expression is labeled by a line with an F. And the capital F in the expression is labeled by a line with a T. End of description of image. The form, quote, xi, and symbol eta, close quote, thus. Reader's note. The following is a description of an image. The top horizontal bracket, which connects the F in capital T, xi, capital F, to the F in capital T, eta, capital F, is labeled with an F. The next horizontal bracket, which connects the F in capital T, xi, capital F, to the T in capital T, eta, capital F, is labeled with an F. The next horizontal bracket, which connects the T in capital T, xi, capital F, to the T in capital T, eta, capital F, is labeled with a T. The bottom horizontal bracket, which connects the T in capital T, xi, capital F, to the F in capital T, eta, capital F, is labeled with an F. End of description of image. Hence the proposition not symbol bracket P n symbol not symbol Q close bracket runs thus. Reader's note. The following is a description of an image. The top bracket connects the T stemming from the F in capital T, Q, capital F, to the F in capital T, P, capital F, and is labeled with an F, which is in turn labeled with a T. The next bracket contains the T stemming from the F in capital T, Q, capital F, to the T in capital T, P, capital F. It is labeled with a T, which is in turn labeled with an F. The next bracket connects the F stemming from the T in capital T, Q, capital F, to the T in capital T, P, capital F. It is labeled with an F, which is in turn labeled with a T. The bottom bracket connects the F stemming from the T in capital T, Q, capital F, to the F in capital T, P, capital F. It is also labeled with an F, which is in turn labeled with a T. End of description of image. If we put quotes P instead of quotes Q and examine the combination of the outermost capital T and capital F with the innermost, it is seen that the truth of the whole proposition is coordinated with all the truth combinations of its argument, its falsity with none of the truth combinations. 6.121. The propositions of logic demonstrate the logical properties of propositions, by combining them into propositions which say nothing. This method could be called a zero method. In a logical proposition, propositions are brought into equilibrium with one another, and the state of equilibrium then shows how these propositions must be logically constructed. 6.122. Whence it follows that we can get on without logical propositions, for we can recognize in an adequate notation the formal properties of the propositions by mere inspection. 6.1221. If, for example, two propositions, quotes P and quotes Q, give a tautology in the connection, quote, P implies symbol Q, close quote, then it is clear that Q follows from P. For example, that quotes Q follows from quote, P implies symbol Q and symbol P, close quote, we see from these two propositions themselves, but we can also show it by combining them to quote, P implies symbol Q and symbol P colon implies symbol colon Q, close quote, and then showing that this is a tautology. 6.1222. This throws light on the question why logical propositions can no more be empirically confirmed than they can be empirically refuted. Not only must a proposition of logic be incapable of being contradicted by any possible experience, but it must also be incapable of being confirmed by any such. 6.1223. It now becomes clear why we often feel as though, logical truths, must be, postulated by us. We can in fact postulate them insofar as we can postulate an adequate notation. 6.1224. It also becomes clear why logic has been called the theory of forms and of inference. 6.123. It is clear that the laws of logic cannot themselves obey further logical laws. There is not, as Russell supposed, for every type, a special law of contradiction, but one is sufficient, since it is not applied to itself. 6.1231. The mark of logical propositions is not their general validity. To be general is only to be accidentally valid for all things. An ungeneralized proposition can be tautologous just as well as a generalized one. 6.1232. Logical general validity we could call essential as opposed to accidental general validity. For example of the proposition, all men are mortal, Propositions like Russell's axiom of reducibility are not logical propositions, and this explains our feeling that, if true, they can only be true by a happy chance. 6.1233. We can imagine a world in which the axiom of reducibility is not valid, but it is clear that logic has nothing to do with the question whether our world is really of this kind or not. 6.124. The logical propositions describe the scaffolding of the world, or rather they present it. They treat of nothing. They presuppose that names have meaning, and that elementary propositions have sense, and this is their connection with the world. It is clear that it must show something about the world that certain combinations of symbols, which essentially have a definite character, are tautologies. Herein lies the decisive point. We said that in the symbols which we use something is arbitrary, something not. In logic only this expresses, but this means that in logic it is not we who express, by means of signs, what we want, but in logic the nature of the essentially necessary signs itself asserts. That is to say, if we know the logical syntax of any sign language, then all the propositions of logic are already given. 6.125. It is possible, also with the old conception of logic, to give at the outset a description of all true logical propositions. 6.1251. Hence, there can never be surprises in logic. 6.126. Whether a proposition belongs to logic can be calculated by calculating the logical properties of the symbol. And this we do when we prove a logical proposition. For without troubling ourselves about a sense and a meaning, we form the logical propositions out of others by mere symbolic rules. We prove a logical proposition by creating it out of other logical propositions by applying in succession certain operations, which again generate tautologies out of the first, and from a tautology only tautologies follow, Naturally, this way of showing that its propositions are tautologies is quite unessential to logic, because the propositions from which the proof starts must show without proof that they are tautologies. 6.1261. In logic, process and result are equivalent, therefore no surprises, 6.1262. Proof in logic is only a mechanical expedient to facilitate the recognition of tautology where it is complicated. 6.1263. It would be too remarkable if one could prove a significant proposition logically from another, and a logical proposition also. It is clear from the beginning that the logical proof of a significant proposition and the proof in logic must be two quite different things. 6.1264. The significant proposition asserts something, and its proof shows that it is so. In logic, every proposition is the form of a proof. Every proposition of logic is a modus ponens present in signs, and the modus ponens cannot be expressed by a proposition. 6.1265. Logic can always be conceived to be such that every proposition is its own proof. 6.127. All propositions of logic are of equal rank. There are not some which are essentially primitive, and others deduced from there. Every tautology itself shows that it is a tautology. 6.1271. It is clear that the number of primitive propositions of logic is arbitrary. For we could deduce logic from one primitive proposition by simply forming, for example, the logical produce of Frege's primitive propositions. Frege would perhaps say that this would no longer be immediately self-evident. But it is remarkable that so exact a thinker as Frege should have appealed to the degree of self-evidence as the criterion of a logical proposition. 6.13. Logic is not a theory, but a reflection of the world. Logic is transcendental. 6.2. Mathematics is a logical method. The propositions of mathematics are equations, and therefore pseudo-propositions. 6.21. Mathematical propositions express no thoughts. 6.211. In life, it is never a mathematical proposition which we need, but we use mathematical propositions only in order to infer from propositions which do not belong to mathematics, to others which equally do not belong to mathematics. In philosophy the question, why do we really use that word, that proposition, constantly leads to valuable results. 6.22. The logic of the world, which the propositions of logic show in tautologies, mathematics shows in equations. 6.23. If two expressions are connected by the sign of equality, this means that they can be substituted for one another. But whether this is the case must show itself in the two expressions themselves. It characterizes the logical form of two expressions that they can be substituted for one another. 6.231. It is a property of affirmation that it can be conceived as double denial. It is a property of 1 plus 1 plus 1 plus 1, that it can be conceived as 1 plus 1 plus 1 plus 1 6.232. Frege says that these expressions have the same meaning but different senses. But what is essential about equations is that it is not necessary in order to show that both expressions, which are connected by the sign of equality, have the same meaning. For this can be perceived from the two expressions themselves. 6.2321. And that the propositions of mathematics can be proved means nothing else than that their correctness can be seen without our having to compare what they express with facts as regards correctness. 6.2322. The identity of the meaning of two expressions cannot be asserted, for in order to be able to assert anything about their meaning, I must know their meaning, and if I know their meaning, I know whether they mean the same or something different. 6.2323. The equation characterizes only the standpoint from which I consider the two expressions, that is to say, from the standpoint of their equality of meaning. 6.233. To the question whether we need intuition for the solution of mathematical problems, it must be answered that language itself here supplies the necessary intuition. 6.2331. The process of calculation brings about just this intuition. Calculation is not an experiment. 6.234. Mathematics is a method of logic. 6.2341. The essential of mathematical method is working with equations. On this method depends the fact that every proposition of mathematics must be self-evident. 6.24. The method by which mathematics arrives at its equations is the method of substitution. For equations express the substitutability of two expressions, and we proceed from a number of equations to new equations, replacing expressions by others in accordance with the equations. 6.241. Thus the proof of the proposition 2 times 2 equals 4 runs, bracket, omega superscript v, close bracket, superscript mu prime, regular script x equals omega superscript v times mu prime regular script x def. Omega superscript 2 times 2 prime regular script x equals bracket omega superscript 2 close bracket superscript 2 prime regular script x equals bracket omega superscript 2 close bracket superscript 1 plus 1 prime regular script x equals omega superscript 2 prime regular script omega superscript 2 prime regular script x equals omega superscript 1 plus 1 prime regular script omega superscript 1 plus 1 prime regular script x equals bracket omega prime omega close bracket prime bracket omega prime omega close bracket prime x equals omega prime omega prime omega prime omega prime x equals omega superscript 1 plus 1 plus 1 plus 1 prime regular script x equals omega superscript 4 prime regular script x. 6.3. Logical research means the investigation of all regularity, and outside logic all is accident. 6.31. The so-called law of induction cannot in any case be a logical law, for it is obviously a significant proposition, and therefore it cannot be a law a priori either. 6.32. The law of causality is not a law, but the form of a law. 6.321. Quote, law of causality, close quote, is a class name, and as in mechanics there are, for instance, minimum laws, such as that of least actions, so in physics there are causal laws, laws of the causality of form. 6.3211. Men had indeed an idea that there must be a, quote, law of least action, close quote, before they knew exactly how it ran. Bracket, here, as always, the a priori certain proves to be something purely logical. Close bracket. 6.33. We do not believe a priori in a law of conservation, but we know a priori the possibility of a logical form. 6.34. All propositions, such as the law of causation, the law of continuity in nature, the law of least expenditure in nature, etc., etc., all these are a priori intuitions of possible forms of the propositions of science. 6.341. Newtonian mechanics, for example, brings the description of the universe to a unified form. Let us imagine a white surface with irregular black spots. We now say, whatever kind of picture these make, I can always get as near as I like to its description, if I cover the surface with a sufficiently fine square network, and now say of every square that it is white or black. In this way I shall have brought the description of the surface to a unified form. This form is arbitrary, because I could have applied with equal success a net of triangular or hexagonal mesh. It can happen that the description would have been simpler with the aid of a triangular mesh. That is to say, we might have described the surface more accurately with a triangular and coarser than with the finer square mesh, or vice versa, and so on. To the different networks correspond different systems of describing the world. Mechanics determine a form of description by saying, all propositions in the description of the world must be obtained in a given way from a number of given propositions. The mechanical axioms. It thus provides the bricks for building the edifice of science, and says, whatever building thou wouldst erect, thou shalt construct in some manner with these bricks and these alone. Bracket. As with the system of numbers, one must be able to write down any arbitrary number. So with the system of mechanics, one must be able to write down any arbitrary physical proposition. Close bracket. 6.342. And now we see the relative position of logic and mechanics. Bracket. We could construct the network out of figures of different kinds, as out of triangles and hexagons together. Close bracket. That a picture like that instanced above can be described by a network of a given form asserts nothing about the picture. Bracket, for this holds of every picture of this kind. Close bracket. But this does characterize the picture. The fact, namely, that it can be completely described by a definite net of definite fineness. So too, the fact that it can be described by Newtonian mechanics asserts nothing about the world. But this asserts something, namely, that it can be described in that particular way in which as a matter of fact it is described. The fact, too, that it can be described more simply by one system of mechanics than by another, says something about the world. 6.343. Mechanics is an attempt to construct according to a single plan all true propositions which we need for the description of the world. 6.3431. Through their whole logical apparatus, the physical laws still speak of the objects of the world. 6.3432. We must not forget that the description of the world by mechanics is always quite general. There is, for example, never any mention of particular material points in it, but always only of some points or others. 6.35. Although the spots in our picture are geometrical figures, geometry can obviously say nothing about their actual form and position. But the network is purely geometrical, and all its properties can be given a priori. Laws, like the law of causation, etc., treat of the network and not what the network describes. 6.36. If there were a law of causality, it might run, quote, there are natural laws, close quote. But that can clearly not be said. It shows itself. 6.361. In their terminology of Hertz, we might say, only uniform connections are thinkable. 6.3611. We cannot compare any process with the, quote, passage of time, close quote. There is no such thing, but only with another process. Bracket, say, with the movement of the chronometer, close bracket. Hence the description of the temporal sequence of events is only possible if we support ourselves on another process. It is exactly analogous for space. When, for example, we say that neither of two events, bracket, which mutually exclude one another, close bracket, can occur, because there is no cause why the one should occur rather than the other, it is really a matter of our being unable to describe one of the two events unless there is some sort of asymmetry. And if there is such an asymmetry, we can regard this as the cause of the occurrence of the one and of the non-occurrence of the other. 6.36111. The Kantian problem of the right and left hand, which cannot be made to cover one another, already exists in the plane, and even in one-dimensional space, where the two congruent figures, A and B, cannot be made to cover one another, without reader's note. There is an image depicting 3 dashes, a 0, a line, an x, 2 dashes, an x, a line, a 0, and 4 dashes. The first line is labeled A, and the second line is labeled B. Moving them out of this space, the right and left hand are in fact completely congruent, and the fact that they cannot be made to cover one another has nothing to do with it. A right-hand glove could be put on a left hand if it could be turned round in 4-dimensional space. 6.362. What can be described can happen too, and what is excluded by the law of causality cannot be described. 6.363. The process of induction is the process of assuming the simplest law that can be made to harmonize with our experience. 6.3631. This process, however, has no logical foundation, but only a psychological one. It is clear that there are no grounds for believing that the simplest course of events will really happen. 6.36311. That the sun will rise tomorrow is a hypothesis, and that means that we do not know whether it will rise. 6.37. A necessity for one thing to happen because another has happened does not exist. There is only logical necessity. 6.371. At the basis of the whole modern view of the world lies the illusion that the so-called laws of nature are the explanations of natural phenomena. 6.372. So people stop short at natural laws as something unassailable, as did the ancients at God and fate. And they are both right and wrong, but the ancients were clearer, insofar as they recognized one clear terminus, whereas the modern system makes it appear as though everything were explained. 6.373. The world is independent of my will. 6.374. Even if everything we wished were to happen, this would only be, so to speak, a favor of fate, for there is no logical connection between will and world, which would guarantee this, and the assumed physical connection itself we could not against will. 6.375. As there is only a logical necessity, so there is only a logical impossibility. 6.3751. For two colors, for example, to be at one place in the visual field is impossible. Logically impossible, for it is excluded by the logical structure of color. Let us consider how this contradiction presents itself in physics, somewhat as follows. That a particle cannot at the same time have two different velocities, in essence, that at the same time it cannot be in two places, in essence, that particles in different places at the same time cannot be identical. It is clear that the logical product of two elementary propositions can neither be a tautology nor a contradiction. The assertion that a point in the visual fields has two different colors at the same time is a contradiction. 6.4. All propositions are of equal value. 6.41. The sense of the world must lie outside the world. In the world, everything is as it is, and happens as it does happen. In it, there is no value, and if there were, it would be of no value. If there is a value which is of value, it must lie outside all happening and being so, for all happening and being so is accidental. What makes it non-accidental cannot lie in the world, for otherwise this would again be accidental. It must lie outside the world. 6.42. Hence also there can be no ethical propositions. Propositions cannot express anything higher. 6.421. It is clear that ethics cannot be expressed. Ethics is transcendental. Ethics and aesthetics are one. 6.422. The first thought in setting up an ethical law of the form, thou shalt, is, and what if I do not do it? But it is clear that ethics has nothing to do with punishment and reward in the ordinary sense. This question as to consequences of an action must therefore be irrelevant. At least these consequences will not be events, for For there must be something right in that formulation of the question. There must be some sort of ethical reward and ethical punishment, but this must lie in the action itself. And this is clear also, that the reward must be something acceptable, and the punishment something unacceptable. 6.423. Of the will as the subject of the ethical we cannot speak, and the will as a phenomenon is only of interest to psychology. 6.43. If good or bad willing changes the world, it can only change the limits of the world, not the facts, not the things that can be expressed in language. In brief, the world must thereby become quite another. It must, so to speak, wax or wane as a whole. The world of the happy is quite another than that of the unhappy. 6.431. As in death, too, the world does not change, but ceases. 6.4311. Death is not an event of life. Death is not lived through. If by eternity is understood not endless temporal duration, but timelessness, then he lives eternally who lives in the present. Our life is endless in the way that our visual field is without limit. 6.4312. The temporal immortality of the human soul, that is to say, its eternal survival after death, is not only in no way guaranteed, but this assumption in the first place will not do for us what we always tried to make it do. Is a riddle solved by the fact that I survive forever? Is this eternal life not as enigmatic as our present one? The solution of the riddle of life in space and time lies outside space and time. It is not problems of natural science which have to be solved. 6.432. How the world is completely indifferent for what is higher. God does not reveal himself in the world. 6.4321. The facts all belong only to the task and not to its performance. 6.44. Not how the world is the mystical, but that it is. 6.45. The contemplation of the world, sub specie aeternae, is its contemplation as a limited whole. The feeling that the world is a limited whole is the mystical feeling. 6.5. For an answer which cannot be expressed, the question too cannot be expressed. The riddle does not exist. If a question can be put at all, then it can also be answered. 6.51. Skepticism is not irrefutable, but palpably senseless, if it would doubt where a question cannot be asked. For doubt can only exist where there is a question only where there is an answer, and this only where something can be said. 6.52. We feel that even if all possible scientific questions be answered, the problems of life have still not been touched at all. Of course, there is then no question left, and just this is the answer. 6.521. The solution of the problem of life is seen in the vanishing of this problem. Is not this the reason why men to whom after long doubting the sense of life became clear, could not then say wherein the sense consisted? 6.522. There is indeed the inexpressible. This shows itself. It is the mystical. 6.53. The right method of philosophy would be this: to say nothing except what can be said. In essence, the propositions of natural science. In essence, something that has nothing to do with philosophy. And then always, when someone else wished to say something metaphysical, to demonstrate to him that he had given no meaning to certain signs in his propositions. This method would be unsatisfying to the other. He would not have the feeling that we were teaching him philosophy, but it would be the only strictly correct method. 6.54. My propositions are elucidatory in this way. He who understands me finally recognizes them as senseless when he has climbed out through them, on them, over them. He must, so to speak, throw away the ladder, after he has climbed up on it. He must surmount these propositions. then he sees the world rightly. 7. Whereof one cannot speak, thereof one must be silent. End of section 5. End of Tractatus Logico-Philosophicus by Ludwig Wittgenstein. Translated by C. K. Ogden. Recording in memory of Mitchell Edwards.